A very good evening to Mr. Basu, Sahu sir, Pragya
Good
ma'am,
evening.
Minakshi ma'am, and all in lovely intellectual physics aspirants. A very warm and enthusiastic welcome to all the participants for the fifth day of our workshop. This workshop has been a wonderful platform for deepening our conceptual understanding and encouraging us to question and explore the fundamentals of physics beyond textbooks. Each day is helping us develop a more analytical and inquiry-based approach towards learning. As we step into a yet another engaging session, it is a pleasure to introduce our esteemed resource person, Mr. Basu Sahu. He holds BTech in Mechanical Engineering from NIT Raipur and is currently serving as a professional engineer with Indian Oil Corporation Limited, a gold medalist in his discipline. He possesses a strong academic foundation and technical expertise. Beyond his professional commitments, Mr. Sahu has a deep passion for physics and continuously explores fundamental scientific concepts. He is also actively associated with National Anveshika Experimental Skill Test as an evaluator, where he contributes to nurturing experimental skills and scientific thinking among students. His dedication reflects a perfect blend of engineering practice and commitment to science education. Today's session promises us to be a highly thought-provoking as we delve into a topic, Newton laws, how solid are the foundations. During this session, we will explore a very interesting questions such as, is an inertia frame a physical reality or just an assumption? Do Newton laws ever hold exactly in the real world situations? Then we will explore, when does the size of object stop influencing its motion? Are action and reaction pairs always equal and simultaneous? And most importantly, are we using these laws without questioning their limits? I am sure today's discussion will challenge our conventional understanding and encourage us to rethink the very foundations of classical mechanics. So with this, I invite Mr. Basu Sahuji to take over the session and guide us through his fascinating explorations. Thank you.
Thank you, ma'am. Thank you, ma'am. Good evening, everyone. This is our fifth day of the workshop, and it is great privilege for me that I am part of this workshop. Today, we are going to learn something about validity of Newton's law. We know very well there are three laws, and we use in our daily life sometimes, and in mechanics, definitely we use all these law. But the today's session is something different kind of things which we read in our classroom, and sometimes we use this kind of Newton's law without questioning how what is the validity of this law, where it should be used, where it should not be used, and what are the conditions. We don't assume, don't basically pay attention on that and directly use such, just like you can say, suppose you have a pulley questions. Yesterday we have discussed, and in that discussion we have find there are lots of things on that, and it was cleared by sir one by one. Assumptions, what assumptions are basically important for solving that question. In similar note, I am starting this particular session, and this is my first slide. Suppose you have a dynamical problem. Suppose you have given a dynamical problem, and what should be your problem solving approach for solving that particular question? What do you think? What are the main factors which you consider during solving a dynamical problem? Please volunteer anyone to speak out about this particular question.
So one would be what is the motion and what reference frame it has been described as.
Okay, very nice answer.
So can you elaborate dynamical? What does it mean actually?
Dynamical problem means the problem which involves force and motion of the object.
Okay.
That we call dynamical problem. dynamics of basically a body.
So sir, basically we make FBD diagrams.
Okay,
Also, we need to analyze the force and its various applications on the object.
very nice. That means we have concluded three things. First is frame of reference. Second one is force. Third one is what? Third one? What other factors we consider?
On which free body diagram, on which object the force is applying by whom?
Yes, yes. That means system. Very
System,
nice.
yes.
What other factors also we should consider or keep in mind?
So
Is there anything left?
is some conditions, if they are given in the question, we consider those conditions also, like air resistance or maybe friction.
Very nice. That means you want to say some assumptions. Assumptions is very important in physics because we deal or we modulate some real problem in terms of physics in very simple way. Sometimes there is air resistance, sometimes friction we omit, or sometimes acceleration we omit. So these kind of things we do so that our problem can be simpler for understanding or some purpose can solve also some purpose of our daily life. So I'm starting this. Suppose you have problem, a dynamical problem. Out of these four things we have understood now: frame, force, free body diagram, and conditions, assumptions. In which one is first thing which you will consider? Matlab, the start of solving problem solving start from that particular factor. Is it force? You directly consider force or free body diagram or frame of reference or assumptions. Which you consider first?
Assumptions.
Assumptions. Okay.
For me, force. On by whom and where?
Okay. For others?
So first we select the system and then we will do analysis of that particular system.
What about frame of reference?
Sir, probably we need to analyze the dynamics of the object with reference to a particular frame of reference and
Hmm.
then describe everything according to that frame of reference.
That means you want to emphasize that frame of reference is your first priority, Sarma sir?
Yes, sir.
Yes.
Yes, frame
Uh,
of reference should be the first priority.
Yes, the frame of reference should be the first priority because the question solving approach starts from this. If you don't know your frame of reference, even you cannot specify a velocity for the object. Sometimes it is already given in the question. The velocity of this object is v, acceleration of this object is a. But just ask yourself with respect to which this velocity, which frame of reference this velocity is given to you. It is not given to any random frame of reference. It is inside the question. You have to read between the sentences what this velocity is given to which frame of reference. So frame of reference is our first priority and the first important factor from the we start our solving our question. Next one is system. If you don't know about the system to which body we call system. Suppose there is a multiple body, uh, just like yesterday problem. Two masses are connected with the string. So which we call basically system. Mass M1, mass M2, or pulley and string. Which you want to say it is a system.
Sir, for which we are interested in doing the study.
Yes, system definition is very easy, for which you want to make some study. Suppose you want to specify acceleration or something you want to study, that will become basically system. indirectly you have earlier said for which you want to draw free body diagram is a system, because you want to analyze for the body everything, you want to study what is the velocity, what is the acceleration for the body. So we basically draw free body diagram for the that particular body, and we call this as a system, and rest other are known as a surroundings, you can say. But in a multi-particle body, multi-particle system, there may be more than one system. You can draw more than one free body diagram. Each free body diagram will basically generate a system. Next priority is important, is basically next factor that will affect our free body diagram, that is assumption. What assumption you are making? Without proper knowing the assumption, you will not able to draw a proper free body diagram, because there may be some friction force available there, and in the question it is already given, you have to you do not have to basically consider that friction force. If you are applying this friction force, then you are in trouble. So assumption is our next factor. You should clearly know about that, what kind of assumption you are basically putting forward for solving this particular question. Next thing is that force. Forces on system means, what do you mean by this? Forces on system. Is it internal force or external force? Is what? What kind of force is this?
External force.
External force.
External force. So what do you mean by internal force?
So which the
Force
particle
that changes the state or that changes the coordinates of the system.
Actually, there is a very thin line between external force and internal force. If a system is comprises of n particles and we are selecting ith particle, then we have to consider internal force on ith particle is also one kind of external force. मतलब every particles which are uh, basically pulling or pushing that particular particle, even though it is internal, but it will account as a external force. Is it clear?
Yes, sir.
If we
Clear.
will consider, okay, so if it is clear, then we will not emphasize more on the force on system, because due the course we will learn about this. We should move to our next basically slide. It is very interesting slide of Mahabharat. You know this, Arjun is aiming. So in all four factors, frame, force, FVD, and assumptions, which you will uh, basically say which part is basically force, frame of reference in this context. Bird eye represent what in this particular picture? What is the bird eye? What do you think about this? What is this?
so system.
System. System.
Yes, very nice answer. It is basically system, because we want to study about bird eye for this particular context. And what is the frame of reference? What should be the frame of reference? Is it Grudon or Arjun? What do you think?
Arjun.
Dronacharya.
Dronacharya. Okay. Any other?
Sir, we can consider both of them as frame of reference depending upon the observer.
Okay. Very nice. Very nice. It may be considered both of them as a observer or frame of reference. But I considered here Arjun as a frame of reference and Grudon like me, who is solving the problem. Because basically, I am saying Arjun to say, please keep on eye on that particular eye of the bird. And what about the forces? Where you will account the force? Till now, we have discussed this. What
At the
about the
eye,
force
At the eye.
force by
at the
arrow on the eye.
IAS system.
eye? Force
The,
by arrow on the eye. It may be force on the arrow. Sorry, eye on the force on the eye may be the basically force. Of course, it is obvious on the figure also. You can identify what we can consider as a force.
Sir, the Arjun is pulling up. So he is applying the force on the bow and the
But
string.
we have already assumed Arjun as a frame of reference.
Okay. So Dronacharya is your frame. Arjun is a frame of reference. Okay, okay. System
Let us
is your.
not discuss much more because it is just I wanted to fun out of this. Basically, force we can consider here, and it doesn't mean a dynamical problem. It is not like a dynamical problem. It is just for resemblance. I have put this on the slide. Let us go. What do you understand by frame of reference and observer? It is very important because every mechanics start from here. If you don't know frame of reference, if you don't know observer, then you really don't know about the mechanics. So what is meaning of frame of reference and what is meaning of observer? Is it same or something different?
So frame of reference
Different.
is set of coordinates with time.
The
Set of
frame of
coordinates.
reference is that frame with respect to which we measure our motion, etc. An observer is someone who is observing the whole process or the motion.
That means, ma'am, you have some
Maybe different. They may
connotation.
be different.
Okay,
Maybe
they
different.
may be different. I am speaking about in terms of only physics. You just think about in terms of physics, not in terms of real life. What is meaning of these two terms, frame of reference and observer?
So observer has to be part of a frame of reference.
Okay, observer should be part of frame of reference. Is it a single person or more than one person?
I mean, for any motion, the observer should be in that frame of reference because he's measuring all the coordinates and everything from that frame of reference only.
That means you are saying a person is on the frame of reference and he is measuring some location or position or velocity of the object, just like he is following the object, then only he can measure, or what is the other method through which he can observe the velocity or acceleration of the body?
Sir, frame of reference could be the system with relative to which we are describing the motion, and whereby, with reference to that system, that is reference frame, we can describe certain laws to describe the motion completely.
Okay, that means you are considering system. What do you mean by system? System means you want to consider like some reference body.
Exactly.
To
Like Earth is system itself, so Earth can be considered as one frame of reference.
that means it is just like a reference body, right? You want to say like that, reference body through which we are analyzing some motion or and all, right?
Yes, sir. Yes, sir.
But just a simple question, frame of reference and observer are two different entity or same entity in terms of physics?
Frame of reference and observer together, I feel, make the system. So
Frame of
reference,
reference together with observer, it makes basically same. Matlab, ma'am, please once again you repeat. What is
frame of
reference?
reference and observer together makes the system, while the observer generally is out of the frame of reference and observing the dynamics happening in the frame of reference.
They are the same.
Okay. That means somehow we have the connotation observer like a human, right? And frame of reference like some coordinate system.
Yes.
Is it like that?
Yes, sir. By and large, yes.
Okay. But this understanding is wrong. Basically, observer is synonym of frame of reference in terms of physics. Here the meaning of observer is only act of observation. There is no human connotation for this. It is not like a human body. No doubt, in general, I have also included in the slide. We will show some basically a human kind of thing as a observer. But please remember, observer and frame of reference, both two are the synonyms of each other in terms of physics. It is observer means only act of observation. Suppose if you say a observer is standing at the origin, then just suppose if observer is standing at the origin, then how he can observe velocity, position of a body at every time? It is not possible without helping through his friends. He has to basically suppose a body is moving in x direction and he is standing at the origin, and if you start t is equal to 0, suppose time start time of the that object is t is equal to 0, and you want to measure, then how would you measure? You have to basically tell your friends stand at the starting point of the object, and some other intervals your friends will be stand there, and they will record at which time that particular ball is passing from there or object is passing from there. Then only he can measure. And this type of observation is indirectly mathematically we do with the help of coordinate system. We and synchronized clocks. That
Sir,
means frame of
kindly
reference.
repeat again. The frame of reference and the observer is synonyms of each other, right?
Yes, ma'am.
Then observer. Then if you are asking your friend to stand and the ball is passing through that point with respect to that coordinate and time, is that you are also standing in the, it is not necessary you are also standing in the same frame of reference?
It is not necessary. But if we are assuming like that, ma'am, then we have to stand somewhere, and that should have the proper knowledge of the coordinate.
Right.
And accordingly, we will correlate with our friends. So basically, what we are doing, we are basically generating some coordinate system with the help of our friends. It is not like one observer can do everything. There will be lots of observer. So these kind of things we do with the help of coordinate system. And for the measurement of time, suppose we have lots of friend in and around uh, in the coordinate system, suppose, or somewhere where the a ball is moving, then we have with in our friends basically what they have clocks, and every clocks have some readings, and all clocks are synchronized. What do you mean by synchronized? Synchronized means all clocks have some reading. Suppose at the same time all clocks read something. They might be 7 o'clock, sometimes they might 7:05, but we have the proper knowledge. Suppose Ram has a clock and that reads 7 o'clock, and Syam has another clock that reads 7:05. That means 5 minute difference between them, and that difference is throughout maintained for the motion. If he reads something, that will be interchanged with the help of initial another clock in terms of Ram. If Syam is taking some readings, then that will be converted in terms of Ram. That is meaning of synchronized clock. It does not mean that all clock will read a same time. It does not mean.
Hmm.
So this is basically meaning of frame of reference. Is it clear, ma'am?
Analogy I am taking, for example, in the earth, different places have different time, but we refers to GST or IST app as per uh, meridian time. So meridian
Yes, ma'am.
time,
Yes, ma'am.
that is the frame of reference, and we have a different places we have synchronized clock. We mean to say that, but we should know that our clock is in this system, and because my coordinate system where my clock and where your clock is there is different system, different coordinate system. Yes. Thank
That
you.
means a frame of reference comprises of two things, basically coordinate system, and second one is synchronized clock. It is not a simply clock, synchronized clock. Next, we very know the inertial frame and non-inertial frame. What is difference between this inertial frame and non-inertial frame?
In inertial frame, Newton's laws holds, and in non-inertial frames, Newton's laws does not hold.
What do you mean by Newton's laws, ma'am? It is you are telling also about third law?
Yes, of course.
That means third law is not valid in non-inertial frame, you want to say?
Yeah.
Okay.
Sir,
What about others?
if the frame is accelerating, then we say it is non-inertial.
Uh, if you say a frame is accelerating, just clear speak about with respect to what?
With respect to observer.
And observer means what? Observe. We understood now, just now, na, कि observer and frame of reference are same thing.
So sir,
With
observer
respect to
is
the
also
object,
accelerating in the same frame of reference of the accelerating body.
You are telling two different things. You are telling observer is also accelerating with respect to that particular body.
Yes, sir.
No, it is not like that.
Sir, if the body is changing position with time, in this frame,
Hmm.
is motion is relative, ना? तो
Yes.
तो इसमें आपको सेकेंड फ्रेम तो लेना ही पड़ेगा, एक जैसे बस के अंदर है और बस के बाहर है. सो
Hmm.
बस के अंदर जो ऑब्जर्वर है, बस के बाहर जो ऑब्जर्वर है, उनका हम लोग सिस्टम ले सकते हैं, लेकिन उसमें हम लोग को फोर्सेस अलग अलग हो जाएगी.
ठीक है मैम, हमें सबसे पहले ये समझना है, what we have to understand first, when we say a body or a system is moving with velocity v or is accelerating with acceleration a, first ask yourself with respect to which frame of reference or with respect to which observer. The same thing. You have to just ask. If you don't know about that, that means you
Right.
nothing you don't know. So if we say, in general, if we say in our physics book in problem, every time it is clearly written, a bus is moving with velocity v or a object which is moving with acceleration a, it's clearly mean it is with respect to which frame? Earth frame. It is not written anywhere, but it is clearly indicated, means we are considering everything with respect to earth frame. This is the basically a main thing. Now the just we have understood कि inertial frame is a frame of reference. Somebody told it is in which all Newton's law is valid, but in non-inertial frame all Newton's law is not valid.
Yes, sir. Now I got
Is
it.
it the correct definition?
That means the body which is inside the bus is the, if you are taking the first frame of reference, it is fixed in earth, may appear to the rest relative to the second. If the हम लोग को दूसरा फ्रेम ऑफ रेफरेंस लेते हैं तो सेम मोशन में रहेगा, तो अगर हम
हाँ
बस के बाहर है तो हम उसको अलग देखेंगे, जो बस के अंदर है अलग देखेंगे। जो मोशन में है तो वो बाहर अर्थ के साथ फिक्स से वो मूव कर रहा है ना सर, तो वो एक अलग फ्रेम ऑफ रेफरेंस हो जाएगा। और जो बस के बाहर है वो फिक्स्ड है, और वो देख रहा है बस बाहर जा रही है, आगे जा रही है, तो उसका फ्रेम ऑफ रेफरेंस अलग हो जाएगा ना, ऑब्जर्वेशन अलग हो जाएगा ना।
हाँ हाँ बिल्कुल बिल्कुल, both have different observation and laws of mechanics will be follow accordingly.
राइट।
Laws of mechanics we apply according to our frame of reference. लेकिन my question is here, what is an inertial frame? How we define an inertial frame? This
I
is the
think,
basic
sir,
question.
in that it is generally talking about the uh, invalidity of the first law of motion, specifically about inertia. And in the second law, we talk about the momentum connected to the force. So where we have to bring in the fictitious forces. Third law basically doesn't directly talks about the motion. This is what my understanding of the situation is.
Just you repeat the second law of motion, what you said about fictitious
The
forces.
The second law of motion is basically connecting force with the momentum also. There is one more definition that F is equals to change in the momentum with respect to time, dp by dt.
Right, right,
So when I am talking about the momentum, there, if there it's a non-inertial frame, in the non-inertial frame to make this valid, one can bring in fictitious forces.
right,
So
right. You correctly said.
the question is focusing, or the when we say inertial non-inertial frame of reference, the focus is specifically on first law and not the second and third. And that is my understanding. You can enlighten us more
Yes,
on
ma'am.
this.
Yes, ma'am. Yes, ma'am.
The
You
second
correctly
law,
said.
I think, also included there. In accelerating frame of reference, second law does not hold. But in inertial frame, second law holds. So second law is also included. I'm not sure about the third law.
Okay, this is the right point out. But I will do the lecture. I will collect all these questions and accordingly modulate this session also, so that we can understand what we are saying with respect to what, with respect to that. Accordingly, some questions are there. You will get every answer for all these discussions, but right now I am not taking these questions. I am just defining how an inertial frame is defined. Ma'am, as ma'am said, inertial frame is defined with the help of Newton's first law. Basically, the frame is designed in a such a way, or it is the characteristic of the frame is a such a way the Newton's first law governs there. If it is not, or the frame which is not defined by Newton's first law, that means the frame is basically non-inertial. But as another ma'am, Mamta ma'am, I think said that the Newton's second law also tells about something, whether the frame is inertial or not. It is absolutely correct, because Newton's second law holds only on the inertial frame. So there is two method through which we can check whether it is inertial or not. So these two method we can check. Basically, if you have what first law say, it clearly speak about in the absence of external force. But sometimes in real situation, it is very difficult to remove all the external force. Then what we have the left option? We have the left option is only second law. If second law is not being hold there on that frame, that means that frame is basically non-inertial. So through these two, all we will see what is the next.
एक बार फिर सर, एक बार फिर आपने जब
मैम व्हाट आई एम सेइंग कि न्यूटन फर्स्ट लॉ से हम बेसिकली इनर्शियल फ्रेम को डिफाइन करते हैं. द फ्रेम which is defined by Newton's first law is basically inertial frame. And इन द इनर्शियल फ्रेम न्यूटन सेकेंड लॉ होल्ड्स। अगर न्यूटन सेकेंड लॉ होल्ड्स नहीं कर रहा है किसी फ्रेम ऑफ रेफरेंस में, तो वो फ्रेम ऑफ रेफरेंस इनर्शियल नहीं है, सिंपल सा मतलब है। क्योंकि समटाइम्स इन रियल सिचुएशन इट इज वेरी डिफिकल्ट टू गेट रीड ऑफ ऑल एक्सटर्नल फोर्सेस, क्योंकि जो फर्स्ट लॉ की डेफिनेशन है, इफ एक्सटर्नल फोर्स इज नॉट प्रेजेंट देन the object will be continue to in rest or in motion will continue in rectilinearly, means constant velocity. So these conditions sometimes we don't obtain in our real life problem. तो इसलिए हम सेकेंड लॉ पे जाते हैं समटाइम्स, कि अगर हमें सही सही पता करना है ये फ्रेम इनर्शियल है या नहीं है, तो हम सेकेंड लॉ से भी पता कर सकते हैं। इट इज नॉट नेसेसरली कि फर्स्ट लॉ ही हमें चाहिए, लेकिन फर्स्ट लॉ ही डिफाइन करता है इनर्शियल फ्रेम को, सेकेंड लॉ डिफाइन नहीं करता। सेकेंड लॉ फर्स्ट लॉ मतलब इनर्शियल फ्रेम पे होल्ड करेगा, ये बताया गया है। वाई इट इज इंपॉर्टेंट फॉर अस कि हमें इनर्शियल फ्रेम चाहिए, नॉन इनर्शियल फ्रेम से भी तो काम चल सकता है, एवरीबडी नोज अबाउट दिस, बट वाई इट इज इंपॉर्टेंट फॉर अस?
So second Newton's second law we will apply on the object which is in the inertial frame, or if it is accelerating. So if you clarify this.
सर एक्चुअली ऑब्जेक्ट इज नॉट ऑन इनर्शियल फ्रेम। ऑब्जेक्ट को जो जैसा मोशन कर रहा है वो ऐसा मोशन कर रहा है। ऑब्जेक्ट ऑन द यूनिवर्स इज जस्ट डूइंग हिज जॉब। उसको पता ही नहीं है कि वो कहाँ मोशन कर रहा है, क्या मोशन कर रहा है, जो भी उसमें एक्सटर्नल फोर्सेस हैं अकॉर्डिंगली दैट इज डूइंग इट्स जॉब। नाउ इट इज आवर जॉब टू एनालाइज द मोशन ऑफ दैट पर्टिकुलर बॉडी। अब वो मुझे एनालाइज करने के लिए आई हैव बेसिकली टू ऑप्शन। फर्स्ट ऑप्शन इज टू फाइंड आउट एन इनर्शियल फ्रेम, और सेकंड ऑप्शन इज आई हैव टू फाइंड आउट एन नॉन इनर्शियल फ्रेम। बोथ वे आई कैन बेसिकली एनालाइज द मोशन ऑफ द बॉडी। इससे फर्क ही नहीं पड़ता कि वो मोशन कर रहा है, मुझे किससे एनालाइज करना है। मुझे द फर्स्ट क्वेश्चन आई हैव स्टार्टेड, that important thing is that frame of reference. Once we have decided this is the frame of reference, we have to ask whether this frame of reference is inertial 1 or non-inertial 1. If the frame of reference is inertial 1, that means the Newton's second law will holds. Accordingly, we will apply the force equations. But our frame of reference, we know very well it is not inertial frame of reference. Then we have to apply some pseudo force or fictitious force, or we say inertial force. These kind of things we have to apply for the analyzing the motion of that body. तो ये कभी मत बोलिए कि the body is moving on inertial frame of reference or something. No, we are analyzing with the help of some frame of reference, and we have to find out whether that frame of reference is inertial frame of reference or it is non-inertial frame of reference. I am clear, sir?
Sir, the meaning of saying the inertial frame, that it coordinates should not be accelerated. How we will find out like this is inertial frame?
Very good question. I will come to this point. Very good question. We will see the in the next slide also. Lekin the first important thing is why it is so important for us. Anyone please throw some light on
Sir,
this?
Sir, probably I may be wrong. With the help of initial frame of reference, we can validate the Newton's law.
What is need of to
First
validate
law.
Newton's law? It is not necessary. What is meaning to validate Newton's law, Newton's second law?
First law. I'm talking about the first law. We can validate the first law, and in the conditions whereby we can check the second law as well. Also, we can make our calculations. It makes the calculation easy.
Yes, the things
To
you
find
said
the net
easy.
forces acting.
Find the net force acting. Okay, net force means external force, ma'am.
External forces acting on the system.
Yes, this may be another viewpoint. Yes, मैंने सोचा नहीं था ये viewpoint. Thank you, ma'am.
The
But
type
as sir
of
said,
the type of
our
references actually changes the explanation of the motion. If it is inertial, then Newton's laws can be applied. If it is not inertial, then some other forces come into play. So it changes the explanation of motion.
Yes, obviously it changes explanation of motion. But ma'am, changes when we say changes explanation of motion, that means with respect to our frame of reference, as Satrupa ma'am also said, the frame of reference basically the description of motion always changes, may changes, not always changes, may changes, may change. So that means frame of reference is there. If you are observing something with the help of some frame of reference, that means everything will be described with the help of that frame of reference only. If you will comparison to frame of reference, there may be some change. If a body is moving a straight line, that may be look like in some circular path. In some frame of reference, it may look like.
Sir.
But the question is why it is so important, inertial frame is so important for us, because the laws of motion is very simple. Very simple. What is that? F is equal to ma. Because there is no fictitious for nothing. It is just simple F is equal to ma. Whatever we have discussed till now, I am going to summarize. Suppose a frame of reference is fixed on the earth, right? Frame of reference is fixed on the earth. I am uh, here putting some Newton kind of cartoon here as an observer. But remember, the observer and frame of reference are same thing in physics. How would you analyze this? Can you tell me what kind of force is acting on this particular bob when the truck is accelerating? I am clearly written here. Truck is accelerating with respect to which frame? S frame. With respect to ground. That means inside everything, including bob, that particular driver, car, everything is accelerating with respect to ground with acceleration A. So what are the forces a ground observer will observe?
F is equals to ma.
Ma'am, before directly jump on the F is equal to ma, let us conclude directly one by one. What are the forces? First, we have consider a frame of reference. Then we want to draw free body diagram for basically Bob. Bob is our system. Now assumption is simply here. There is no drag force and all. No other planets are there nearby us. Just we are thinking about this. No, and we are considering Earth as a inertial frame. These are basically assumption, or other assumption you can take. This rope has no mass. It is inextensible. This kind of assumption is there. Under all these assumptions, just draw a free body diagram of this bob. What will be the forces? Now tell me.
Tension along the string.
Tension along string, very nice.
Mg.
mg.
Mg, right. Any other force?
Yes, sir. Acceleration by it is giving F equal to ma in the right hand side. It is a minus Fa in the left hand side of the bob.
Why minus ma, ma'am?
Because I am observing from the ground, na? I am so I can see the truck is moving with in the positive direction with respect to the earth. That is positive. And but if I take the coordinate system, so it is if I take the point of suspension as a coordinate system in the inside.
No. Don't jump on the coordinate system fixing on the truck or at a point of suspension. Don't jump on that. You are everything you are observing from the ground.
ठीक है, तो मैं तो इधर एक्स एक्सिस पे अगर ट्रक जा रहा है, उसका रिएक्शन फोर्स ही तो मिल रहा है इसको बॉब को.
कौन सा रिएक्शन फोर्स?
जो फोर्स है वो पूरा सिस्टम को लेके जा रहा है विद द बॉब एंड ट्रक. तो बॉब तो यहाँ पे अलग हो जा रहा. अरे नहीं नहीं नहीं, या mg
Sir, for the
Depending on
observer,
motion.
the bob is also moving with the same acceleration as the truck is moving.
Right, right,
yes,
right. For
लेकिन it is
for the
negative होना, negative दिखेगा, इसको पीछे दिखेगा ना.
नहीं मैम, आपको जो दिख रहा है आप वही बताइए अभी इस स्टेज पे, आप कुछ अलग मत बताइए। आपको क्या क्या दिख रहा है, जो आप देख पा रहे हैं वो यही है कि अर्थ is basically attracting that bob, and
हम्म
that in terms of force, if we say mg, and
हम्म
there is a tension force along the
हम्म
string, that's
हम्म.
all. And everything is accelerating, including driver, bob, everything is accelerating. There is no
then
other
then
forces present.
then why the bob is coming not in the x direction, it is coming in the left hand side.
How we will see why it is going on the left direction. We will see.
हाँ, okay, okay. हाँ,
Suppose
it
this
is
is
a thing.
mg.
हम्म
Suppose this is mg. This is
हम्म
tension T. We will
हम्म
resolve this tension T in x and y direction. I am assuming
हम्म
this is x direction and this is y direction. So accordingly, this will be T cos theta and Ty sin theta.
हम्म.
What will be the equation of motion for this
Sir,
system?
T cos theta will be equals to m into A.
Yes.
T cos theta is equal to m into A, because
M into
this is the driving force. This is the driving force which is accelerating this bob with acceleration A. This is meaning of this. And here there is no acceleration in y direction. That's why the right hand side is 0, because m into acceleration in the y direction is 0. And t cos theta is working upward, t sin theta is working upward, and this is downward. That's why it is in minus sign. So this is the equation of motion for this particular system. Newton is happy here. Observer from the frame of reference is happy here, because we are able to applying Newton's second law. What about next figure? As you said, ma'am, when we fixed frame of reference at on the basically this car, or even here at the point of suspension, even here on the bob, is the difference in all these basically frame of reference?
Yes.
No.
No, actually,
No.
here only
Anything,
that. Yeah. Yes, yes, sir. Please.
anything fixed on the basically
It's the
this
same.
lorry,
So there will be
everything.
no acceleration due to the truck because Newton is inside the truck. So there will be no effect of acceleration for this bob for Newton.
First of all, we have to understand what is meaning of a frame of reference when we say with respect to that frame of reference. When you say with respect to that frame of reference, you inherently assume everything is stationary. Not everything, matlab the frame where the reference body, where the frame of reference is fixed, is basically stationary. First, you consider this. This is the meaning of with respect to frame of frame of observation, basically observation with respect to that frame of reference. Whenever you say we are observing something with respect to some frame of reference, that means the reference body where that frame of reference is fixed is basically stationary. That's why when we are fixing this frame of reference s dash on the lorry, yeah, inside the lorry, that means we are considering truck is stationary with respect to frame s dash. This is meaning of basically with respect
Yes,
to
sir.
something. ठीक है? Now what we have again, this observer is observing t cos theta here, t sin theta here, mg in this direction, and he wants to write some equation with the help of Newton's second law. He is failed to write because there is no counter force for t cos theta, and Newton is perplexed here. What should we do now? तो हम लोग क्या करते हैं? फिर क्या करते हैं?
Pseudo force लेके आइए ना.
Obviously. तो हमें क्या करना है? What we understand, if a frame, just decide whether this frame of reference is inertial or non-inertial. First, you say this.
Which one? For you are talking
S
about
dash frame of reference S dash.
Non-inertial.
non-inertial होगा ना?
Whether we are applying Newton's first law or second law.
ओनली सेकेंड लॉ होगा सर, क्योंकि उसमें तो फ्रेम ऑफ रेफरेंस रेस्ट तो है ही नहीं, उसमें दोनों के ऊपर एक्सटर्नल फोर्स यूज हो रहा है, न्यूटन के ऊपर भी बॉब के ऊपर भी।
नहीं
I think
मैम,
both.
आप दो चीज नहीं, what is both मैम? I didn't understand.
First
मैम
and second law.
सेकेंड लॉ मतलब यहाँ पे तो जो बॉब का सिचुएशन है वही आपका सिचुएशन आपका ऑब्जर्वर का भी है। बॉब 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 जहाँ पे मतलब बॉब को वही देखेगा जहां से लटक रहा है, वो तो सेम फ्रेम ऑफ रेफरेंस में पीछे कैसे देखेगा या आगे कैसे देखेगा? वो तो उसी जगह पे देखेगा।
हाँ, मतलब ये जहां पे है वहीं पे देखेगा बोल रहे हैं ना बॉब?
हाँ 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 हाँ
हाँ हाँ, वो ठीक है। एवरीथिंग इज स्टेशनरी विथ रिस्पेक्ट टू दिस फ्रेम ऑफ रेफरेंस, इनसाइड आउट दिस ड्राइवर कार, एवरीथिंग इज स्टेशनरी फ्रीज्ड। जैसे कि महाभारत की लड़ाई में हो गया था ना फ्रीज, वैसे यहाँ पे भी हो गया, एवरीथिंग इज फ्रीज नाउ। बट इन दिस फ्रीज हमको ये समझ में आया, वी आर नॉट एबल टू अप्लाई न्यूटन सेकेंड लॉ, टी कॉस थीटा का हमें कोई कंपोनेंट नजर नहीं आ रहा। दैट्स व्हाई वी आर सेइंग दिस फ्रेम ऑफ रेफरेंस इज बेसिकली नॉन इनर्शियल, बिकॉज अगर ये हम अप्लाई नहीं कर पा रहे हैं तो हमें ये इनहेरेंटली पता है कि ये इनर्शियल फ्रेम जो है वो नॉन इनर्शियल होगा। तो समटाइम्स हमारे दिमाग में ऐसा रहता है ना कि वी रियली नीड फर्स्ट लॉ ऑफ न्यूटन फर्स्ट लॉ टू डिफाइन इनर्शियल फ्रेम और नॉन इनर्शियल फ्रेम। वो है, वो
है।
एक्सपेरिमेंटली वैसे ही करना है, लेकिन समटाइम्स एक्सपेरिमेंटली वो हमें पता नहीं चलता है उस टाइप से डिफाइन करने के लिए, पता ही नहीं है हमारे पास। यहाँ पे मैं जितने भी फोर्सेस लग रहे हैं, टी कॉस थीटा टी साइन थीटा, मैं इसको कैसे यहाँ से हटाऊं? इट इज वेरी डिफिकल्ट कि इसको हटाना है मुझे। तो वो उस टाइप से एक्सपेरिमेंट कर पाना जहां पे एफ इजिकल टू जीरो हो और फिर मोशन को एनालाइज
Sir, one
करना,
small
वो बहुत
request,
डिफिकल्ट
sir.
हो जाता
Excuse me, sir, one small request. Sir, I request you
है।
to speak in English, sir. I could not understand Hindi.
Okay.
Sorry.
What I am saying, sometimes it is very difficult to get rid of all external forces. It is very difficult. On that case, we apply Newton's second law to identify whether our frame of reference is basically inertial one or non-inertial. In this case, we are not able to apply Newton's second law. That's why we can directly conclude, yes, this frame of reference is basically non-inertial. Then what is the next? We will see whether we have to apply some fictitious force or what, and how that will come and how we will account for that. So what Newton is thinking here? Newton is clearly thinking, array, it is very difficult, F is equal to ma is not holding. Then we have just, there are several conversations like what is inertial, non-inertial, and in the inertial discussion we have seen such kind of thing. All frame of reference which are accelerating with respect to inertial frame are non-inertial frame. This is the correct definition. Not this is the correct concept. Basically, this is not definition of non-inertial frame. Please remember, this is not the definition of non-inertial frame. This is basically correlation. With the help of inertial frame, we are able to identify the characteristic of the frame as a non-inertial frame. All frame of reference which are accelerating with respect to inertial frame are non-inertial frame, and non-inertial frame are those frame in which Newton's second law does not hold. The definition of non-inertial frame is only this, where Newton's second law is not hold. That is basically non-inertial frame. But if you know a inertial frame, then you can easily identify a non-inertial frame with respect to this statement. Manish sir, are you saying something?
Sir, just out of curiosity, like if we are standing in inertial frame and we are observing that bob, and we are seeing that bob is going leftwards, So what justification from the inertial frame we can give that why the bob is going leftward?
Actually, Bob is during the motion, Bob is not going to left. If you consider the statement of the problem, it is already there because we have considered that part of the question where the Bob is already there because that is also accelerating with respect to A. Truck is also accelerating with respect to A. It is not about initial position. This will happen during initial movement. After taking acceleration A as a constant, the bob will be remain at that point. So you are mixing two problems. First problem, you are thinking bob is going left. I am saying bob is already there. Both are two different things. Because when you say bob is going there, that means you are considering some variable acceleration. Start v is equal to 0 to taking some velocity and acceleration, and after that that acceleration is become constant. When the acceleration become constant, the bob will remain stationary at that position with respect to truck, but at the initial position that will move, and that movement will account with some different philosophy. Are you getting my point?
Uh, so you are saying that in when the truck has started or accelerated, in that situation, the somehow that bob is left behind with the truck. So because and
Yes.
then once they get the same acceleration, they are the position remain fixed.
Meant, yes, if the we increase the acceleration, the position will going left, 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 and it can be easily understood by basically even uh, inertial frame and also with the help of non-inertial frame. But with the help of non-inertial frame, it is very easy to explain this to why it is going left. We will see. We will see if time allows. I will take your question. Okay.
Okay, sir.
Sir, sir,
Yeah.
excuse me, sir. I
Yes.
have one doubt. In the previous case where the observer is inside the truck, so the
Huh.
observer is also moving with the same velocity as that of the truck. So, can't we consider this as the constant velocity motion and therefore the inertial frame of reference?
Ma'am, in the second case, when I say with respect to frame S dash, that means you are considering truck, driver, that Newton observer, Bob, everything as stationary on that frame. Nothing is moving. You just think about train. When you are inside the train, you just consider yourself as a stationary, and everything outside of the train you consider as a movable bodies. Why it is so? Because we consider ourselves as a stationary. With respect to me, basically trees are moving, everything outside the train are moving with respect to me because I consider myself as a stationary. The same logics apply here. You just apply here. If you say with respect to this frame of reference s dash, matlab truck, this particular observer, table, lamp, bob, everything inside the truck, everything is stationary for the sake for the problem solving. But if you will observe all these things from the ground, then everything is movable. This is basically perception, how you perceive the problem.
We consider
because
relative motion
because
actually.
what
To
you said,
solve
ma'am?
the not to
We
solve
consider
the
the relative motion actually. In this case, when
huh,
Newton is inside, there is no relative motion. So it's stationary.
no relative.
When he was
Yes.
outside, the motion was relative between these two.
Yes, yes, yes. Here, no relative motion because every thing has the same velocity, same acceleration. That's why, with respect to ground, I am saying again, when we say velocity or acceleration, just ask with respect to Which frame of reference? So with respect to ground, I am saying Bob, this particular Newton or frame of reference S dash, driver, this particular lorry, everything is moving with respect to ground floor with the same velocity, same acceleration. That's why when you consider frame of reference S dash, then there is everything is stationary with respect to that because there is no relative motion. This is the logic. Is it clear, ma'am?
Regarding, yeah,
Yes.
yeah.
Yes.
So I would also like to maybe just add my justification, whether you please tell me whether it's correct or not. See, in this, so assume that the door is completely closed. So Newton is sitting inside the truck and he is seeing the what are the forces applied on the acting on the bob. So obviously, as the t sine theta, in downward is mg, so they cancels, and in the horizontal direction, forward direction, t cos theta. Now, since there is a force on the horizontal direction, but he sees that the bob is at rest. So if we try to apply the
Yes.
second law, this is a perfect. So that is where we can conclude that it is not an inertial frame. So there is a
Yes.
force, but there is no acceleration, which means it is against the Newton's second law. So there is a perplexity. So it is the indication because we don't need to open the door and see whether it is inertial or not. So just looking at the bob and seeing that there is a force, but there is no acceleration means definitely there is an issue with the frame of reference. So absence
Yes.
of inertial frame is nothing but the accelerating frame. So that is what I feel.
Yes. Yes, yes, yes. Yes, yes, sir. Yes, sir. Definitely, you are correctly said. But it is not basically closing of the door or something else. But yes, we can assume like that कि we don't know about outside the world what is going on. If you just consider nothing is going on, because when you open this door, you can see everything is basically moving uh, in opposite direction. But what else? Even you know, in the train where you have seated, in front of you somebody has seated, there is no relative motion. But with respect to the inertial frame, with respect to the ground, everything is moving. This kind of situation is here also. Is it clear to everybody? Shall we move for the next?
Yes, sir.
So we have just studied all frame of reference which are accelerating with respect to inertial frame are basically non-inertial frame, you can say. In non-inertial frame of reference, Newton's second law does not hold. We have already understood this. Then what we have to do? We have to apply some pseudo force, which I have written here, Fp. And on that frame of reference, right side will also modify. This is not Ma, rather it is M A prime. A prime signifies acceleration of the body with respect to which frame? S frame or S dash frame?
Yes, frame.
S dash frame, right.
Yes, just
We all know this about. My next question is, do you really think an inertial frame of reference exists? This is a poll question. Let me open the poll first. Yes or no, you have to say basically. I have launched poll. Please evaluate yes or no. Just response. Do you really think an inertial frame exists?
No. No absolute frame of reference exists.
Okay. Everyone, please help me in this particular question. I really don't know it is exist or not. You just tell me whether it is exist or not. If it is not, then why? If it is yes, then why?
It does not exist, as Madam said, because you will never have zero acceleration frame in the universe. Everything is relative.
Okay, this might be answer, ma'am. We'll evaluate your answer later on.
because we cannot eliminate all the forces. Never possible to remove all such forces completely. For example, if you take a ball and rolling on the ground and it stops, if the force and other forces completely limit the ball, it will go on moving, but it is not happening. So,
Ma'am, Satrupa ma'am, please excuse me. Just I am stopping you because already 19 teachers have evaluated this particular problem. Please do fast so that we can move to for other slides.
अच्छा, मैंने नो लिखा है, मैं करेक्ट हूँ कि नहीं बता दीजिए बस.
Ma'am, अभी नहीं. Just we will discuss. 20 participants have already polled the question. Please do fast.
So may I add something?
Sir, not this stage. We will take all your observations after one more question. Please participate in the poll question so that our understanding can be strengthened, because it is very important what we really think about an inertial frame. चलिए ठीक है. There are 21 participants who carried out the poll. I am ending the poll and showing the result. Is it visible to everyone?
Yes, sir.
1/3 participant has
Sorry, I could not
voted.
see the poll, sir.
Okay.
But
Okay,
I
just you say
replied.
yes or just you say yes or no.
No, I said no.
No. Okay. That means 15 participant voted for no, and 7 participant voted for yes. Okay. Let me carry out another poll. Stop sharing, back. Launch the poll. Is it visible?
Yes, sir.
As per your understanding, which one is an inertial frame? Earth, distance star, center of Milky Way, center of mass of nearby galaxy.
So I have given the answer based on what you had asked in the previous poll. But if you ask for like an approximate version, then there are different possibilities. Is that all right? Right now,
Yes,
I'm
ma'am.
assuming. Right now, I'm assuming you are asking for for again from the previous question, the absolute inertial frame. Otherwise, I
Yes,
can
we
put a
are.
ranking.
Yes, ma'am. We will take your ranking. We will take your ranking.
So shall I put it in the chat then? Because I have already answered as one. One answer is already submitted. Okay, thank you.
Okay, ma'am. "24 out of 35 had participated. Should I stop or somebody is doing?" Very nice. 26. Okay, let's stop poll. Let me show result to you. Is it visible to everybody?
Yes, sir.
Major vote for none of these, 13. After that, Earth, we are saying it is inertial frame. Then 3 votes for distance star, then center of Milky Way. Even 2 votes for center of mass of nearby galaxies. Now we can discuss why it is inertial. We have inertial frame exist or not, yes or no. Now we can discuss.
So can I?
Yes.
Sir, how I thought.
First, tell me what is your voting for, yes or no?
For the first question, I voted for yes.
Okay.
And the reason that I thought, uh, although inertial frame is not something physical entity, so it's just for our convenience to apply, as you said, Newton's laws, because if we apply Newton's laws, then in inertial frame it is very easy. So we can assume on earth also, we can assume on other, it depends upon the situation. So uh, for me, inertial frames exist.
Okay. That means, for your point of view, inertial frame exist. What others? What other think about this? Yes or no? Let me take for no. What they have the reason to choose the no?
Everything is in relative motion to something else. So there is no absolute frame of reference. But for our convenience, we take, if we are on Earth as a inertial frame.
Ma'am, when we say motion, what do you mean by acceleration or velocity? What is important for consideration of non-inertial frame? Whether it is velocity or acceleration?
Acceleration.
Acceleration. Okay. That means you are saying everything is accelerated with respect to something, right?
Yes.
In broader sense. Actually, you are saying in broader sense. I am also saying in the broader
We
sense.
are on Earth and Earth is rotating. That is an accelerated type motion. We can't say that it is
Okay.
in constant velocity with respect to us. So
When we say Earth is rotating, ma'am, then with respect to what? What it is rotating?
rotating on its own axis and revolving around the
Okay. So can we assume Sun as a inertial frame? Have you heard about
for Earth. Can
for Earth?
assume, but it is not.
Okay. What about Sun? Sun is inertial frame or not? With respect to what?
It is not an inertial frame. It is again in a Milky Way galaxy.
Rotating around Milky Way galaxy.
In Milky Way galaxy.
In Milky Way galaxy. Matlab it is revolving around the center of Milky Way, you want to say, right?
Yes, sir.
And what about ranking? Ma'am, you want to say something about ranking?
Ranking.
Sir, I think I have put it in the chat.
I have not
So,
thought about that, sir.
Ma'am, this is the time. Please read out because I am not able to see the
no
chat.
worries. So, what I was thinking in this way is, if I have to really consider the most approximate inertial frame, the number one would be Earth, because we are on Earth, and for everyday activity, we will consider Earth as our inertial frame. After that, then the second choice would be the distant stars, center of Milky Way, and then the center of mass nearby galaxies.
I will
With
go
respect
for the
to
reverse
choice,
order.
you are saying that.
Yeah, the
With,
options you give, with the option that
with,
you give based on that.
with respect to basically choice means
So
to
my first
analyze the problem.
to analyze the problem, first would be Earth.
First would be the Earth, right? But
Yes.
with respect to physics, in strict sense,
in strict sense, so for the Earth would be the first choice because everyday activities are on Earth.
okay. Okay, Mamta ma'am, do you want to add something?
I will take the reverse order, sir.
Okay. Why you will take reverse order?
Because the nearby galaxies means nearby galaxies near Milky Way. It is at far more distance away from us. So it can be considered as stationary, and then Milky Way, then star, and then Earth for us.
Yes.
Sir,
Just a
Let
guess.
us.
sir, I want to say something. Hello.
Yes, sir, बताइए. हाँ, yes, sir. Sir, बताइए.
Sir, observer is on the earth. Then with respect to
Okay.
observer, the earth is stationary. So It is inertial frame, and
Hmm.
if we don't consider it, then the last option should be correct, none of these.
Hmm. Last option is correct, none of these. Yes, this is also the correct way. But in what sense we are saying, whether we are saying this particular question in the sense of solving problem, or we are saying with the in the sense of basically mathematical concept, in what sense we are saying, accordingly the answer will be framed for this question. Everybody is on the same page, but I am explaining what I want to say. Suppose here is sun, and we are assuming sun as a reference frame, as an inertial frame. If we say sun is an inertial frame with respect to sun, if this earth is revolving around the sun, that means it has a centripetal force. That means with respect to sun, earth has some centripetal acceleration. Means earth has some centripetal acceleration. If I fix some frame of reference on the earth, that means that frame of reference is accelerating with respect to sun. And I have already told you, if we have identified an inertial frame, and with respect to that inertial frame, if some inertial frame is accelerating, then that inertial frame will be basically non-inertial. If I say center of this earth as inertial frame, then I know that the earth is rotating about its axis. That means on the earth, everything, if I choose on the earth any frame of reference to analyze the body, that frame of reference will also a non-inertial frame, because that is accelerating with respect to the center. Similarly, complete earth is revolving around the sun, that is also accelerating with respect to sun. And what is the acceleration? We can easily see when we assume uh, when we fix our inertial frame at the center of the earth, then any frame which is fixed on the surface of earth at equator will have acceleration 0.034 meter per second square. That's why in all practical problems on the earth, sometimes we don't consider this acceleration, and often we assume uh, frame of reference fixed on the earth as a inertial frame, because we do not consider this acceleration, effect of this acceleration. If we consider next thing, the centripetal acceleration of the earth revolving around the sun, that is approximate 0.006 meter per second square. That means with respect to sun, the acceleration on earth is very small. That means if you assume sun as an inertial frame, then there will be very little mistake. Error, inherent error is very little when you assume sun as a reference frame. But what about sun? Sun is also revolving around the center of Milky Way, which we call as a black hole, Sagittarius A star. And about Sagittarius A star, not only the sun revolves, even in galactic plane that oscillate like this. Four oscillation, sun completes. And it takes I think 230 millions year. And when what about the earth and other planets around the sun? That moves like this. This is sun is moving in this path, and other planets are moving like this. You can see sun is also not stationary, but we are more curious about acceleration. What is the acceleration? The centripetal acceleration of sun towards the center of galaxy is just 2 into 10 to the power minus 10 meter per second square. It is very tiny. That means if you consider center of Milky Way as inertial frame, then there is, in all practical purpose, absolutely there is nothing, no special error or some intrinsic error. Intrinsic error is there, but no major error, you can say. What about center of galaxy of Milky Way? Center of galaxy of Milky Way, in fact, complete Milky Way galaxy and other approximate 10,000 galaxy, nearby galaxy, are moving towards great attractor with speed 600 kilometer per second. That means everything is moving, everything is accelerating in the space. That's why, in truly speaking, we don't have any inertial frame in real sense. All inertial frame is just a mathematical quantity. All real frames are non-inertial frame in a strict sense, but obviously we omit that non-inertiality character and just assume as a inertial frame. Inertial frame is just mathematical concept, I earlier said, and a frame of reference can be classified either inertial or non-inertial frame. That means whatever we studied till now is that a frame of reference can be either inertial or non-inertial. We cannot compare two frame of reference with respect to this frame of reference is inertial, or with respect to this frame of reference it is not inertial. This is not kind of thing. Inertial frame is either frame of reference is either inertial or non-inertial. Don't club two things. With never compare with respect to some inertial frame, because I have earlier said with respect to inertial frame, any accelerating frame is basically non-inertial frame. It doesn't mean that with respect to a frame we are comparing some other frame. Inertial or non-inertial is inherent characteristic of a frame of reference. Please remember this. This is very important concept. We often do mistake here. We always compare a frame with respect to another frame, and this is the biggest mistake. Don't do this mistake. Let me now say, now what is your opinion that inertial frame really exists? So our answer will be definitely no. In real sense, no inertial frame exists. It is just a mathematical quantity, because we cannot find a frame of any body which is stationary in absolute space. Space we call absolute, absolute in rest. There is nothing like, and there is nobody which is absolute rest position. That means everything is moving in the space. Now let us take next question. See this problem. This will enhance your basically thinking capability. Suppose a car is moving with respect to velocity. Suppose a car is moving with a constant velocity relative to ground. Another car is moving with acceleration a relative to car A. Now we are comparing two frame of reference, car A and car B. What will be the answer? I am opening the poll. This question will really help you for understanding what we think about inertial or non-inertial. This is very interesting question. And what kind of language we use for frame of reference, you will understand from this question. I have lot of thing to discuss, but we have only half an hour. How could we fast? I don't know. But lots of thing to discuss. This is very difficult. Till now, 18 posts have received. Please finish as soon as possible so that we can start our discussion. 19.
Sir, this is indeed a tricky question.
It is not tricky question, ma'am. Actually, it
A
will
concept,
open
I
your
mean,
mind.
it really, yeah, tricky in the sense it really asks us to think about the concept very clearly.
Yes, yes. Actually, what happened, ma'am? Sometimes we intermixed various things, inertial, non-inertial, with respect to this, with respect to that, but we really don't think what we are saying actually. That is the
Uh,
problem.
no, and I would think this would be a nice question for the student as well, because this will really make them think whether they understand the concept of inertial and non-inertial frame correctly or not. So thank you so much for posting this question.
Thank you, ma'am. Thank you so much. It's mean a lot. Okay, I am stopping poll here because time is very less for me and lots of things to discuss. I am sharing the result. Mostly, I have seen 16 participants have carried out poll for option A. After that, second last is inertial car is an inertial frame. Then B and C option are on the same page, and one has basically opted for option number E, none of these. Anyone can say why option A is correct?
The car A is moving with respect to Earth with constant velocity, and B is moving with some acceleration with respect to it. So car B is non-inertial with respect to A as well as with respect to ground.
As well as with respect to?
Actually, there is no acceleration for car A because the velocity is constant. So
One thing I want to disclaimer here, I am assuming inherently ground as an inertial frame and not
yes.
considering any kind of acceleration for the ground with respect to
No,
sun
so
or
with respect to ground, if car A is moving with constant velocity, car A will not have any acceleration. Velocity is constant. So A can be approximately treated as inertial frame, considering the definition of inertial frame. And what madam said
just
is right.
just we are sticking ourselves as a earth as a inherently as a inertial frame. Just we are sticking on this concept, right?
Yeah.
And accordingly we are saying something. We will see whether what we are saying are correct or not. When we say car B is non-inertial frame with respect to car A, this means we are comparing car A and car B. Actually, I told earlier, a frame of reference has characteristic that is inertial or non-inertial. It is not like that with respect to something. This is the wrong statement. It is okay. It may be car with respect to it. It may be car A is inertial. It may be car B inertial or non-inertial. It is altogether different thing. Car A may be inertial or non-inertial. Car B may be inertial or non-inertial. This is the concept. We cannot compare two frame of reference with respect to each other. In earlier statement also I have said, if a frame of reference is accelerating with respect to an inertial frame is a non-inertial frame. Not with respect to inertial frame. I haven't relate kind of thing. In that sense here, car A is basically moving with constant velocity with respect to ground, and ground I am assuming as an inertial frame. That means car A is inertial frame. It is not like with respect to ground or something. It is an inertial frame. It is an inertial frame. It is not like we are comparing two frame of reference. Now think about B. Since car B is moving with respect to car A with constant acceleration, that means with respect to inertial frame, as car A is already inertial frame, I have identified car A as inertial frame, and car B is moving with respect to inertial frame with constant acceleration. That means car B is non-inertial frame. Again, we cannot say that car B is non-inertial frame with respect to car A. If I will write like that of a statement, then with respect to car B, car A is accelerating. You have to do reverse acceleration for car A. That means with respect to car B, car A will accelerate. That means with respect to car B, car A will non-inertial. So this kind of statement we cannot make. With respect to something frame of reference, their characteristic cannot be defined. The car A may be inertial or non-inertial, that is altogether different thing. Car B may be inertial or non-inertial, that is different thing. But we cannot compare two frame of reference with each other. That's why option A is wrong. Here we are comparing car B as non-inertial frame of reference with respect to car A. That means with respect to car B, car A is non-inertial frame of reference. Sometimes we are saying car A is inertial, sometimes we are saying car A is non-inertial. It is not possible. Whether car is inertial frame of reference or non-inertial frame of reference, it will be defined with the help of Newton's first law. तो ये आपको बहुत क्लियरली समझना है कि वेदर इट इज इनर्शियल और नॉन इनर्शियल, बस इतना ही, दैट मच. With respect to word add.
Sir, can you repeat? So option A is wrong.
Yes, option A is wrong because we are comparing two frame of reference with respect to each other. Frame of reference can be either inertial or non-inertial. It cannot be defined with respect to something. What we are doing here in option A, we are defining inertial or non-inertial with respect to car A. With respect to car A, it is accelerating. That's why we thought it is non-inertial, but it is not like that. With respect to car B, car A is accelerating. That means you will define car A as a non-inertial with respect to A. But the terms inertial or non-inertial, it is not defined with respect to somebody. It is whether a inertial frame is a frame of reference can be inertial or non-inertial. We cannot define like this. With respect to things, we cannot define like this.
So in this case, we have to consider ground as our reference point, and with respect to ground only we have to talk. Am I right to understand?
Yes, ma'am. Only we have to talk. That means basically once we have knowledge about
the inertial frame, the constant
inertial
inertia.
frame, because we are assuming na ki some I have some reference body which in which I have a frame of reference and I am assuming that as an inertial frame. Then basically I will define everything on with respect to that only. We cannot define it. But the definition is something different. Again, I am mixing two things. Again, in the conversation,
No. Why
I am
I'm asking is because there is one more option which says is car A is inertial frame. So if car A is an inertial frame, that option D, if I say that is the correct answer, then I think the first should be valid if I take that as the consideration.
Sir, may I say something?
Yes, ma'am.
Sir, I think what we are saying is that we fix one reference frame, which we are saying is not accelerating. And then with respect to that, we refer everything. That with respect to that, car A is inertial. With respect to that, car B is non-inertial. But we will not compare them with each other. Is that what we are saying?
Yes, ma'am.
Yes.
Because
everything has to be referred to one single reference frame, which we normally say lab frame or something.
Lab frame. Yes, ma'am. Actually, what we have inherently assumed in the physics, lab frame as an absolute one. Even we know that lab frame is not absolute inertial frame kind of things, because absolute inertial frame will be fixed in the space or will move with respect to space with constant velocity. That is basically a mathematical thing. But once we have considered entire ground as a inherent inertial frame, then everything will be defined with respect to ground only. We cannot define two body each other. This is the wrong definition, which I want to explain.
Sir, what the definition you gave earlier about non-inertial frame, that was with respect to inertial frame. The one which is accelerating is non-inertial.
That is only bypass route. If you really want to understand whether it is inertial or non-inertial, we have to apply Newton's first law only. That is the correct way of finding out. Because we are assuming Earth as a inertial frame here, then everything which is moving with respect to Earth with constant velocity or stationary is basically inertial frame. Are you getting my point? Because we have the problem now, we cannot find a real inertial frame. When we don't find real inertial frame, then it is very difficult to understand uh, how we compare to moving things. We have to fix somewhere, we have to limit our boundary, which one we are considering as a absolute inertial frame of reference. Where we are here in this particular case, we are considering Earth as a absolute inertial frame, although we are knowing it is not. Are
Uh,
you getting my point?
in a similar way, can't we take inertial frame in car A, and since it is fitting in all your previous things, like car B is accelerating with respect to car A, or with respect to frame of reference of car A, so the same thing we can apply also.
Let me clarify what I want to say. Just think a hypothetical situation. Earth, there in the universe, only there is a Earth. And Earth is moving with respect to absolute space with constant velocity, right? Now, now Earth is basically our inertial frame because we have defined Earth with respect to space. So whatever is basically moving with respect to Earth will be considered as a inertial frame, but not with respect to Earth. Rather, we are considering inertiality or non-inertiality with respect to space, a frame of reference which is fixed on space or moving with respect to space, and with the help of that frame of reference we can say yes, this is inertial or this is not inertial. What I want to highlight, inertiality or non-inertiality is basically inherent property of a frame of reference. We cannot say with respect to Earth, or we cannot say with respect of something. It is with respect to a mathematical quantity which is fixed, mathematical frame of reference which is fixed on space or moving with respect to space. But we don't have any facility to fix a frame of reference on the is on in the space, or to move with respect to space with constant velocity. That's why we have to choose some reference body, and here the reference body is Earth. We are describing everything on the Earth. And if we want to do any experiment, then if it follows Newton's first law, then we will say this frame of reference is basically uh, inertial frame. On that hypothetical situation, basically what will happen, since Earth is not accelerating, Earth is simply moving with respect to this, that means car A will follow Newton's first law. And it doesn't mean that we are describing the inertiality or non-inertiality with respect to ground. We are indirectly describing with respect to space fixed reference frame. Are you getting my point?
So, sir, to make the thing simpler, we can take always to treat anything on which is happening on Earth. Earth has an inertial frame, and then see everything with respect to Earth. If it is something accelerating, then it would be considered as non-inertial.
Huh. Yes, you can consider, but never compare like two bodies, like car A and car B. We cannot compare because these two body are not part of Earth. If I fix this car A on Earth, then it will be part of Earth. Or since I have assumed uh, Earth as an inertial frame with respect to space fixed inertial frame, that means everything I am comparing with respect to frame of reference of Earth, then accordingly I can decide whether it is inertial or non-inertial. But the definition still lies on the Newton's first law. Whether it holds or not, accordingly we decide. We do not compare two bodies like this. अदरवाइज तो ऐसा हो जाएगा ना कि कार ए का भी मुझे पोजीशन पता नहीं है. If I will comparison like this, then just see option A and option C. According to option B, according to option C, car is non-inertial frame. According to option A, B is non-inertial frame. But you know, if you do experiment on car A, then it will follow the Newton's second law. But if you do experiment on car B, it will not follow the Newton's second law. That means where the Newton's second law do not hold, that frame of reference is non-inertial frame. That's why I'm saying car B has inherent property of non-inertiality, not for car A. We never define like with respect to something. It is not with respect to something. मैं क्लियर कर पाया या नहीं कर पाया इस पॉइंट को?
Sir, may I say something?
Yeah.
Sir, this means the inertiality or non-inertiality of a body that's moving or accelerating will be determined with respect to Earth always. And say, for example, there is an observer standing on Earth, that is, with respect to Earth, he is at rest. So with respect to him also, anything that is moving with a constant velocity can be treated as an inertial frame of reference. And with respect to him, a body that is accelerating can also be treated as a non-inertial frame of reference. Have I understood your point correctly, sir?
Ma'am, this is correctly, but only one rider. We are assuming Earth as a inertial frame. That is the only rider. In some cases, we don't assume Earth as an inertial frame. In that case,
yes,
all things will be non-inertial. Every body will be non-inertial if we fix any frame of reference on that body.
Sir, you said that it's a presumption that Earth is an inertial frame of reference. Based on that only, I said. Hanji. Okay, sir. Thank you. Thank you.
Only 2-3 questions more left. Let me do next poll. Similar question. Please poll it. Ma'am, I will take 10 more minutes. Please allow me.
Sure, sir. Sure.
I am stopping poll here so that we can move ahead. I love to get all the polls, but time is very crucial for us. So let us end poll now. And I am sharing the results. Here the problem is car A is accelerating with respect to ground, and we are assuming ground as a inertial frame with respect to that absolute mathematical inertial frame. Just think like that. And that inertial frame, absolute inertial frame, is fixed on the space or moving with respect to space. Matlab, we are indirectly somehow comparing with respect to that inertial frame of reference. You just think about that. Another car B is moving with acceleration A. So I want to correlate like this. With respect to ground, car A is accelerating. And we are assuming ground A with respect to that absolute inertial frame, it is basically inertial. That means we are transmitting this car A as a basically have a constant acceleration with respect to absolute inertial frame. You can say the term absolute inertial frame. That means car A is basically non-inertial. car A is basically non-inertial. We can conclude like that. What about B? B is basically accelerating with respect to car A. If it is accelerating with respect to car A, that means there can be two situations. It might possible car is stationary. It might possible is stationary with respect to ground. It might possible car B is moving with constant velocity with respect to ground. It might possible car B have some acceleration with respect to ground. Under all these conditions, you will find out with respect to car A, car B may have some acceleration. So just suppose car B is stationary and you are looking with respect to car A. You will find some acceleration because car A is accelerating. It will when we will fix our frame of reference on car A, we will find out car B is accelerating. If car B is basically moving with constant velocity and car A is accelerating, when we will fix our frame of reference on car A, we will find out B will accelerate with respect to car A. Similarly, when suppose car B is moving with constant acceleration, A is equal to say 4 meter per second, and car A is moving with respect to ground with acceleration say 2 meter per second. What will be the net acceleration when we are looking from car A of car for car B? Car B have the acceleration with respect to car A 2 meter per second. It means there may be situation car A can have three situations. It may have acceleration with respect to ground. It may not have acceleration with respect to ground. That means it may have constant velocity or stationary with respect to ground. That means if we are comparing any frame of reference with respect to inertial frame of reference, we have the well understanding for that. That is what, if any frame of reference is stationary or moving with constant velocity with respect to inertial frame, then that is inertial one. Under that note, car B can be inertial, car B can be non-inertial because it can have the acceleration with respect to ground.
So, sir,
And indirectly,
may I
yes.
just understand this? So that means why we should not, why car A is not a, it's not a good idea to take car as the reference, because car A's motion is not always same. It may change. And if it itself accelerates, in that case, car B may or may not be accelerating with respect to car A. So taking the earth as the non-inertial frame, as the inertial frame is the safest bet, because earth's being a non-inertial frame can be ignored since its acceleration is very small. And that is why we should take the earth or the ground as the safest um, uh, reference frame, with respect to which we judge whether car is accelerating, whether car B is accelerating, whether some other object is accelerating with respect to that, and then decide.
Basically, ma'am, there is one more underlying concept on that. When we say uh, car A is accelerating with respect to ground, that means we have fixed a frame of reference on ground.
Correct.
And we have the knowledge of that ground as a inertial frame.
Correct.
And with respect to what? With respect to a mathematical frame of reference which is fixed on a space. Because if it is not comparing, we are not comparing this frame of reference with that absolute frame of reference, that mathematical one, then we may do mistake, because we know now earth is not basically inertial frame of reference. That means we have to compare every frame of reference with respect to that absolute frame of reference which is fixed on
clear.
space or moving with respect to space. In this case, what we are doing, when we have fixed a frame of reference on the earth, we have assumed that frame of reference as inertial frame of reference with respect to that inertial frame of reference. First, we have the well understanding of that. Yes, I am assuming this frame of reference as an inertial frame. So just ask me with respect to what? With respect to that absolute one. Because under that condition, only Newton's second law will hold. Otherwise, Newton's second law will not hold. That means we are somehow indirectly comparing motion of each car with respect to that absolute frame of reference.
So
I am correct,
basically, what we have to decide whether a reference, a given frame of reference is inertial or non-inertial by comparing with a reference frame which is an absolute one fixed in space, imaginary.
This is one way of method. This is mathematical way of method. What experimental way of method says? You just apply Newton's first law or second law, whether it is hold or not. If it is not hold, that means Newton's second law is not holds, means it is simply non-inertial. Simply
Okay.
non-inertial.
Okay.
That
So
means a frame of
one is
reference
the
can
ideal way and the other is the practical way.
practical way, yes,
Okay.
because it is very easy. We can
Clear.
easily say yes, this frame can be inertial, this frame can be non-inertial, but we cannot compare two frames with respect to one frame other frames, like not like that. Car A, car B, we cannot compare with respect to nothing. This is absolute characteristic. Inertiality or non-inertiality is basically inherent characteristic of frame of reference. It is not defined with respect to some frame of reference. Still, when we say car A is inertial, that means we are not defined with respect to ground. It is not like that.
You see, the point is, the confusion is that on one hand, we are saying that it is with respect to an absolute frame. And then we are saying it is not with respect to anything, it is an inherent property. So there, that is why all the confusion is coming, that then we should not be talking about with respect to something. Or does it mean that once we have decided that our reference frame will be the one which is absolute frame fixed in space, and it is for granted that whenever we are talking about a frame of reference being inertial or non-inertial, it goes without saying that it is being compared to that absolute frame in ideal condition. But in daily life, practical conditions, we say that absolute frame which we took to be ideal is, let us say for all practical purposes, it is the earth. And
Yes.
with respect to now our practical reference frame, we will consider whether car A is accelerating or car B is not accelerating. So for this practical purpose, we will consider Earth as our reference.
Yes, ma'am. Yes, ma'am. What you said is correctly right.
But
And if you
supposing car B has acceleration of 0.002 meters per second square. What was the Earth's acceleration in space? 0.03 or what?
I think it was in that range only. With respect to basically around the sun.
Around the sun. So was that 0.03?
0.006.
0.003.
Right. So supposing car B with respect to Earth has an acceleration extremely small, about of the order of, let's say, 0.002. A hypothetical situation. In that case, you are saying that it cannot be considered a non-inertial frame in absolute sense with respect to the Earth. But with respect to that absolute frame, yes, you can consider it to be non-inertial. Is that
Yes,
what?
ma'am. Yes, ma'am. Yes, ma'am.
मतलब अर्थ जो है वो प्रैक्टिकली हमारा रेफरेंस फ्रेम है, लेकिन व्हेन डज इट स्टॉप बीइंग आवर रेफरेंस फ्रेम, प्रैक्टिकल रेफरेंस फ्रेम? व्हेन द ऑब्जेक्ट which is accelerating with respect to the earth has smaller acceleration, or within that range which earth itself has acceleration with respect to that absolute frame.
नहीं मैम, प्लीज रिपीट अगेन व्हाट यू सेड।
चलिए इस बात को हम अलग से कर लेंगे, अभी आगे बढ़ते हैं।
मैम बढ़ने का तो बहुत कुछ है, बट
Sorry to
आई डोंट
interrupt.
नो।
May I add something here?
या
या
Actually, in that case, car A is accelerating with respect to ground, and B might be at rest, stationary. In that case, when B is at rest, considering A as rest, B can be said as accelerating with respect to A with minus A acceleration, if A has A acceleration. Is it this is also a statement that can be say here.
मैम
In
एक
that
सिंपल
case,
फंडा
One
है
more
let's
point, sir.
compare here.
Sir, one more point. The directions of these accelerations also matter, don't they?
Yes,
One
yes.
is parallel. One is
I'm
parallel to the surface, and the other is acting towards the center of the sun. So they are having two different directions altogether.
यस।
What I want to say here is if A is moving in the forward direction with A acceleration, small a, and B is at rest, then in that case, the option D is correct. What was the option? B can be, that was in, it can be inertial or non-inertial, that can be true. Because considering A as our stationary frame, in that case, B will have a acceleration in the opposite direction. We consider the two frame of reference, one as at rest. If it is moving, then we can also consider it at rest, like a train. A moving train, a person moving in, sitting in a train, moving train. For him, the person that are standing on the platform, they appears to move in the opposite direction, or the train that is standing on the platform appears to move in the opposite direction. The same can be considered here. Then that option will be true, that B can be inertial or maybe non-inertial.
मैम बस मैं एक ही चीज कहना चाहता हूँ, वेन एवर यू आइडेंटिफाई अ फ्रेम ऑफ रेफरेंस, it can be either inertial or non-inertial, simply depends on the Newton's second law whether it holds or not. वो हम एक्सपेरिमेंटली पता कर सकते हैं, लेकिन इफ वी एज्यूम समथिंग तो हम उसको ट्रांसलेट कर सकते हैं इन द फॉर्म ऑफ वेदर इट इज एक्सलरेशन और नॉट. सपोज वी आर एज्यूमिंग ग्राउंड एज अ inertial frame, we are forgetting everything. We have stopped our thinking from which with respect to what is it is inertial non-inertial. No, we have stopped our thinking. We have just inherently assumed ground as a inertial frame, and everything which is moving with respect to ground with constant velocity or is stationary on the ground will be considered as a inertial frame, because if we do any experiment or an experiment on that frame, that will follow Newton's second law. That's all. इतना ही सोचना है, उससे ज्यादा नहीं सोचना है, क्योंकि हम जैसे जैसे सोचने लगेंगे हमें ये एकदम क्लियर हो जाएगा. वी विल अंडरस्टैंड दैट कि नथिंग, नो फ्रेम ऑफ रेफरेंस इज बेसिकली इनर्शियल. तो हम व्हाट वी आर डूइंग, नो रियल फ्रेम ऑफ रेफरेंस इज इनर्शियल, बट वी आर गोइंग टू एज्यूम यस दिस इज इनर्शियल, दिस इज इनर्शियल. दिस इज द प्रॉब्लम. यहीं पे प्रॉब्लम है. जो चीज इनर्शियल है ही नहीं उसको हम इनर्शियल बना रहे हैं. उसको वी आर एज्यूमिंग ऑल द मैथमेटिकल थिंग्स इन अ प्रैक्टिकल वे. दैट इज द प्रॉब्लम. वही प्रॉब्लम की शुरुआत है. तो वो इसलिए उसको बाईपास करने का एक रूट खोजा गया है. दिस इज दैट काइंड ऑफ रूट कि डोंट कंपेयर वन फ्रेम ऑफ रेफरेंस टू अनदर फ्रेम ऑफ रेफरेंस, जस्ट कंपेयर वेयर एवर विच एवर यू आर कंसिडरिंग एज ए इनर्शियल फ्रेम. बस उस एक एब्सोल्यूट फ्रेम को मान लीजिए. इसीलिए कुछ लोग हेलियोसेंट्रिक को इनर्शियल फ्रेम मानते हैं, सेंटर ऑफ द सन को इनर्शियल फ्रेम मान करके उसके रिस्पेक्ट में सभी चीजों का डिस्कशन करते हैं. तो वो एब्सोल्यूट रेफरेंस फ्रेम उन्होंने मान लिया. इफ somebody assume center of the Milky Way is the absolute reference of frame, तो उसके रिस्पेक्ट में सभी चीजें बात होंगी. देन ये कार, ये एवरीथिंग, सब एवरीथिंग विल बी नॉन इनर्शियल, बिकॉज वी आर लिमिटिंग आवर सेल्फ. Where we are limiting, just to identify ground as an inertial frame, that means you are limiting yourself to assume ground as a inertial frame, ground as a absolute frame kind of thing. You are assuming, yes, I am assuming ground will be absolute frame of reference. Then you can compare region. You can compare any frame of reference which is moving with respect to that or accelerating. Accordingly, you can define whether it is inertial or non-inertial. But remember, we are limiting ourselves. Yes, Binod sir, and बताइए sir.
Sir, I want to say, can we say that any body which is in constant linear motion will be an inertial frame. And if it is rotating, then it will be non-inertial frame. Is it correct?
सर ऐसा है कि सबसे पहले when we say the word it has a constant velocity, tell me with respect to which frame. First you define.
Okay.
First you clear me this. With respect to which frame? Binod sir, you just convert.
With respect to inertial frame, any say Earth.
With respect to?
Earth. If we assume that it is inertial. Then
Now one
body.
thing, we are assuming or we are inherently taking the characteristic of frame of reference of Earth. There is two different aspects. When we say Earth as a inertial frame, that means we are assuming it is not an inertial frame.
Yes, we are assuming.
With respect to the definition. So anything which is moving with constant velocity or is on rest with respect to Earth, as we have assumed as a inherently, as a ground, as a inertial frame, that means that will basically inertial frame. Or anything accelerating, basically rotating disk is have the always acceleration. Rotating disk, rotating body is always has some acceleration with respect to ground. If we are assuming like that, so yes, rotating disk will have non-inertial frame of reference. यही आप बोलना चाह रहे हैं ना?
जी.
So there are two things. First is assumption. Second is absolute definition kind of things. So definition kind of things is something different and assumption is something different. दोनों चीज अलग अलग हैं. तो आप दोनों को मिक्स मत करिए. What we are doing, हमने एक बार अर्थ को इनर्शियल मान लिया तो मान लिया.
Okay.
और क्यों माना? Because we know why we have assumed like that. Because it has a very tiny acceleration with respect to sun or with respect to center of the earth. लेकिन this is also important when we explain such kind of things like if you drop some ball from 100-meter height or 200-meter height or rocket launching or hurricane, if you want to explain this kind of phenomena on the earth, you have to consider basically that tiny acceleration also, because you know what is the pseudo force. Pseudo force has two component, mass and acceleration. Wherever the body of mass will be greater, then small tiny acceleration will also play the role. तो आपको वो भी समझना होगा कि हरिकेन वगैरह में कोरियोलिस फोर्स ऑल दिस थिंग्स वर्क्स. तो accordingly we have to assume whether sun is inertial or non-inertial. Accordingly we have to apply. And you know the very famous experiment that name is I think Foucault pendulum experiment,
Yes.
which explain Earth is a non-inertial frame of reference. तो एक चीज है assumption, हम assumption क्या कर रहे हैं और उसके दायरे में रह के everything we are describing. So in this particular question is framed like that कि we are assuming Earth as a inertial frame, and according to the definitions of Newton's second law, which car will hold and which car will not hold. इतना ही हमको देखना है. And the bypass route is that if you know very well a frame of reference as an inertial frame of reference or non-inertial frame of reference, in sometimes you can define other frame of reference in terms of whether it is inertial or not. This is what I want to convey.
Okay, thank you.
ममता मैम बताइए, कुछ और है क्या किसी के पास कुछ बोलने के लिए? मेरे को तो बहुत कुछ है बट अब टाइम है नहीं. व्हाट आई कैन डू, आई कैन शेयर माय स्लाइड्स,
So please
बट आई
continue.
वांट टू. हाँ, यस मैम.
So please continue. It's a nice explanation.
मैम मेरे को कोई दिक्कत नहीं है. आई एम रेडी इफ पार्टिसिपेंट्स आर रेडी.
Yes,
व्हाट
of course.
अदर मैम, इफ एनीबडी वांट्स टू गो देन वो जा सकते हैं, बट वी कैन कंटिन्यू. आई एम रेडी फॉर दैट. आई हैव नो लिमिटेशन फॉर दिस.
Yes, we can do like that. If participants
Okay.
are interested, then we can move further for more 10 minutes. 10 to 15 minutes,
you
then
can.
it will be naturally at
You
8
can.
p.m. we will close.
Then I'm not moving the similar questions so that we can understand. I will put this in the, I think we have some problem question also, just we have to
Yes.
solve, you have to solve also. Yes, then I will put all this question there. I'm moving forward. This is the situation. A book is placed over the table, and I have shown reaction force R and sorry, mg. Choose the correct option. Should I use poll? Poll will take time basically, but okay. I am taking the poll and this poll, sorry. Please do quickly so that we can discuss at the given
Yes.
time frame. जो भी आप लोगों के मन में आ रहा है वो कर दीजिए, because my teacher has said a very wonderful thing. What is your first reaction is your reaction. Other reactions are basically you modify according to the current understanding or everything. जैसे अगर हमें 2+2 बोला जाता है तो 4 ही होता है, चाहे हमें नींद में बोला जाए या जागते हुए बोला जाए. वी नेवर से इट इज 5 और नेवर से वी से 3. दैट मीन्स इट इज योर आंसर, दैट इज योर जेन्युइन आंसर. तो फटाफट पढ़िए और आंसर दीजिए, बस ज्यादा सोचिए मत. Sorry, I am a little bit poor in English. I try to manage all these things. And interesting answers I am getting. Very interesting.
Sir, just one thing. Here, the action and reaction, if I take the action of that, the book is being pulled by the earth.
Sir, please don't discuss.
Okay.
I know you have got the answer, but please don't discuss. We'll see that. I'm ending the poll and showing the result. Please tell me why option A is correct. Whoever has answered this. Sorry. Why answer A is correct? Weight is action force and R is reaction force. Why do you think like that? Binod sir, yes, you tell me if you are saying something.
Yes, sir. Because reaction force is caused by the weight, gravitational force.
Okay, that means gravitational force is causing the reaction force, you want to say?
Yes.
Okay. You have also notion that the mg will first act, then R will react, R will appear accordingly. You have notion like that?
Yeah, R will appear afterwards.
Afterwards.
First mg.
Very good. Very good. What about option B? Any other,
mg,
please?
It is also
R.
correct.
Magnitudes are equal, but directions are different.
Okay, that's why it is, you think like that Newton's third law is working here, right?
Yeah.
Very good. What about option C?
In option C, everything is clear. According to Newton's law, reaction is equal and opposite to action. Here, weight of the book on the table is the action force on table, and the reaction by table on book is opposite.
Okay. That means the nature of two forces are same, ma'am?
Yes.
Yes, okay. What about D option?
Incorrect.
Incorrect.
Why even R can be action, mg cannot, can be reaction? Why it is incorrect?
So mg is acting all the time.
mg is first. mg is the cause to produce R.
Cause, right. It is cause. So I am last one. I think two participant has given the answer. None of these. I want to listen. Why none of these?
So, sir, if I can, sir, I think action and reaction, first of all, should be acting simultaneously. It can't be that one is preceding the other. And
Yes.
secondly, it's like they should be of the same kind,
Same nature. You
same
want to
nature.
say?
So, a
Yes.
gravitational force should have a reaction which is also gravitational in nature. And a
Yes.
contact force, like in this case, if we take that of the normal reaction that is being developed, it should also be of the reaction or to it all should also be of the same kind. So it's like when I'm punching the wall, so I am hitting the wall, but the wall is also hitting me simultaneously. Uh, uh,
Yes.
I can only feel the pain once my hand has actually touched the wall and not before that. So that means it should be simultaneous. And secondly, again, it's like when the book, book is pushing the floor of the table is also pushing the cover of the book back. So that is the correct action reaction pair here.
You
That,
want to say like this?
my understanding.
You want to say like this? I have shown in the next slide. This is basically table, and this is force exerted by the book,
Yes, and the
and this is force exerted by the table on the
table,
book,
table, yes,
है ना? And
yes,
you want to say this is weight mg, and it is basically force exerted by the earth,
on the book,
and book is exerting a force
a
on the
force
earth.
on the
This is like
earth.
that.
With, so it's just in
That
this
means
case, numerically, these two come out to be equal. So
yes,
for our mathematical understanding, we take them to solve questions R equal to
yes.
mg. But otherwise, the correct action reaction pair will be the gravitational force of Earth on book and book on Earth. And the correct, again, similarly, contact forces of the your normal reaction will be by the
That
book,
means you
the
want to
table.
say N and R are action reaction pair, and W
Yes,
and F are action reaction pair. Like, right?
yes, sir.
ठीक है, किसी को कोई दिक्कत? Anybody has any problem or some confusion on that? W and R are not action reaction pair, first of all. N and R are action and reaction because it is acting on the same point. ये जहां पे काम कर रहा है वहीं पे है. ये एक्शन रिएक्शन फोर्स है. N and R are action reaction force. W and F are action reaction force. They have the same nature. First of all, they have the same nature. This is also gravitational pull. This is also gravitational force. This is contact force. This is contact force. This is gravitational pull and this is contact force. Nature is something different. These two are not same in nature. तो ये तो एक्शन रिएक्शन पेयर हो ही नहीं सकते. It cannot be action reaction pair. First thing, first concept. Second concept, as sir said, it acts simultaneously. This is very important. It is very misnomer that sometimes we say action will act first, after that reaction will come out. This is not like of that. तो ये एकदम दिमाग से हटा दीजिए कि एक्शन विल प्रीसीड्स रिएक्शन. ये एकदम बेकार स्टेटमेंट है, वेरी रॉन्ग स्टेटमेंट है. डोंट use this statement. Accordingly, I have chosen this question, which sir has already said. N can be action, R can be its reaction. आर कैन बी एक्शन, एन कैन बी इट्स रिएक्शन. इससे कोई फर्क नहीं पड़ता कि किसको एक्शन बोलते हैं या किसको रिएक्शन बोलते हैं. एन एंड आर एक्शन रिएक्शन पेयर. इट डजंट मीन दैट एन इज एक्शन, आर इज रिएक्शन. आर कैन बी एक्शन, एन कैन बी रिएक्शन. एन कैन बी एक्शन, आर कैन बी रिएक्शन. कब हम इसको ऐसा बोल सकते हैं? When we can say like that? Only when it will act simultaneously. This is important underlying concept of Newton third law. It acts simultaneously. That's why in pair nothing is action. मतलब we can say anything as action and another pair as a reaction of that thing. This is the important concept. In this particular case, A, B, C, D, all are the answer. What sir said, मैंने यहाँ वो चीज लिख दिया है.
Sorry, sir.
Action
It means all forces doesn't have reaction forces.
all forces doesn't have reaction.
Reaction for them.
What do you mean by this, ma'am?
Means there is no reaction for weight of the book.
For this particular question,
Yes, sir.
I didn't understand what you want to say actually.
So you said that this is not the exact pair of action and reaction, Mg and R. So
Mg and
I
R are
want,
not action reaction pair.
I am just
R and
confused.
N are action reaction pair
Yeah,
basically.
they are action and reaction. But what about the Mg? It doesn't have any reaction pair.
Here, na ma'am. Here. W is what? W is basically gravitational force by the earth on the book. That is G-M-M-D square.
Yes, sir.
And the same pull force is also experienced by the earth. That is G-M-M-D square.
G. Okay.
So these are the action reaction pair. These two are action reaction pair.
Okay.
Right, ma'am?
Thank you, sir.
Force, all physical force will have action reaction pair. Not all, sorry, not all. I will explain why. No, sorry, all forces will have action reaction pair, but it doesn't mean that they will be equal. Sorry. Interaction force always occurs in pairs, first thing, acting simultaneously. That's why I have written F12T equal to minus sign F21. This minus sign is significance for the action in the opposite direction. And here T means the time which we have chosen act simultaneously. Identical in nature. If it is gravitational, then pair will be also gravitational in nature. If it is contact, then the another one will be also the contact force. If it is electrostatic force, then another one will be also electrostatic force in nature. If it is magnetic in nature, magnetic force in nature, then other will be also magnetic force in nature. तो ये आपको ध्यान रखना है. What is meaning of this? The instantaneous means the propagation of force. Suppose you are applying a force at the some part of the body, instantly आपको एक reaction force मिल जाता है. तो ये एक instantaneous propagations of the force को बताता है. I am quickly moving towards next part so that I can explain what I am saying. Suppose two charge particle Q1 and Q2 are placed at a 1 light year. You know what is 1 light year? Light year is also unit of the length or distance, you can say. That means if a light is if we just start torch here, then it will reach to of this point after 1 year. This is meaning of 1 light year. That kind of distance is there. So if two charge is placed at a distance d, and what they are experiencing F12 K Q1 Q2 d square Coulomb force, you know very well. Up to this point, anybody has any problem?
No, sir.
नहीं.
No, sir.
ठीक है. What will happen if I will change small distance d to d minus x? मतलब I am moving this q particle towards q2 with distance, very small distance x. This will be this force will be given like this. What do you think about F21? Whether it will be equal or not equal?
Equal.
Equal. Manish sir, what do you think? Equal. Everybody is on equal phase?
Say equal, but simultaneously it will not affect.
This is the important underlying concept. Here the force will be Q1 Q2 d square. The time which we are defining this force, at the time this force will be like this. It will take after 1 year, then this Q2 will have the knowledge of that Q1 has shifted to x. Otherwise, it doesn't have any knowledge that Q1 has shifted to x distance. Up to 1 year, the force will be this. Why it is so? We understand this thing in special theory of relativity or in electrodynamics, the maximum speed of any information can be limited to speed of light. Here, the information is being carried by electric field, and when we change the distance here to here, the electric field will be changed, and that information will reach up to this Q2 charge after 1 year. When he will find out that changing position of Q accordingly the electric field, then this charge will experience this kind of force. Up to 1 years, this will feel the same force, k q1 q2 d square. This is very strange. और ये limitation है Newtonian mechanics की. And after that we came up with the field theory.
Pardon,
And we
sir?
know it is.
Pardon,
Yes,
sir?
ma'am.
Pardon,
Huh.
sir? I could not hear.
What I want to say, if Q1 charge is shifted to x distance, it immediately fill Q1 Q2 d minus x square. But after 1 year, Q2 will experience the field which is changed due to the shifting of Q1. And after 1 year, this F21 will be equal to this much amount. Before that, the force will be only k q1 q2 d square. You can see action reactions pair have the different basically force here. Up to 1 year, they are not in same magnitude. तो ये जो चीजें हैं ना, इलेक्ट्रोडायनामिक्स में गड़बड़ हो जाती हैं, या स्पेशल थ्योरी ऑफ रिलेटिविटी में न्यूटन्स थर्ड लॉ काम नहीं करता है. दिस इज द लिमिटेशन ऑफ न्यूटन्स थर्ड लॉ. ये याद रखिएगा. Similarly, I am moving very quickly because already
Just one thing. In the previous situation, like you had taken the distance to be 1 light year. Now, let's say this distance was only a even see any distance will be a fraction of light year only.
हाँ.
So then from going like this information from transmitting from one point to another, some time will be spent in that. That's
Yes.
that means
Yes.
action and reaction will then differ by some amount.
Up to that point, that will differ. Up to that point, whenever they have not the information of the shifting, तब तक वो change होगा.
Okay.
Are you getting my point?
So that's the meaning of saying action will precede sort of.
No, that's not meaning. Here the action reaction kind of thing is not work.
Okay.
What I want to convey, action reaction is not a fundamental concept.
Okay.
It is not a fundamental concept. Fundamental concept is law of conservation of momentum. ये एकदम क्लियर ध्यान में रखिएगा. In Newtonian mechanics, it works very well. Action reaction pair works very well. But in holistic view, the broader sense is law of conservation of momentum. When we say law of conservation of momentum, fields also work. It's play in the momentum. तो यहाँ पे आपको ऐसा लग रहा है कि एक्शन रिएक्शन काम नहीं कर रहा है. इफ आई एम एज्यूमिंग दिस पर्टिकुलर सिस्टम एज अ आइसोलेटिंग सिस्टम, तो हमको ये पता है कि व्हेन वी एज्यूम टू पार्टिकल्स एज अ आइसोलेटिंग सिस्टम या आइसोलेट सिस्टम, देन ऑलवेज law of conservation of momentum works because all forces are internal forces. But here, up to 1 light year, we have found some force difference. Means action reaction pair are not cancelling out each other. Internal forces are not cancelling out each other. You can think like that, but you are forgetting about the field. Field has also momentum. Field, I am again repeating, field has also momentum. That's why Verma said in a very special theory of relativity, a very standard word, our world or our universe is made of what? We earlier said electron, proton, and neutron. But he also added one important thing, field. Our universe is made of electron, proton, neutron, and also fields. And what kind of fields? It is not temperature kind of fields. The fields which carry energy and momentum, like gravitational fields, like magnetic fields, like electric fields. So these are the basic concept which we have understood till now. Vinod sir, do you want to say something?
The same thing as you discussed earlier, that simultaneity is only assumption. By this example, it appears that simultaneity is only assumption.
Yes,
Action
sir.
and
Yes, sir.
reaction takes some time.
Simultaneously. Yes, yes, yes. Even
Whether
action
it be
reaction pair.
millisecond, microsecond, or picosecond, there will be some
Yes,
time.
yes, yes. Lekin what we do in all Newtonian mechanics, whenever we solve the electrostatic problem, just like अगर मैं बोलूं आपने कैथोड रे एक्सपेरिमेंट वगैरह में इसको अप्लाई किया होगा तो इन दैट केस द डिस्टेंस बिटवीन इलेक्ट्रॉन और दैट पर्टिकुलर चार्ज प्लेट्स दे हैव वेरी इलेक्ट्रिक फील्ड दे हैव वेरी स्मॉल डिस्टेंस एंड पिको सेकेंड्स और उससे भी कम सेकेंड्स हम बोले तो दैट विल डजंट मैटर फॉर अस दैट्स व्हाई वी
Okay.
ऑलवेज do like this f q1 q2 and either be q1 q2 d square like that. Are you getting my
Okay.
point? In all
Okay.
small distance, it is always okay. But for a greater distance like 1 light year or 0.5 light year, and wherever we are comparing with light year kind of thing distance, then it matters for us.
So in that
Thank
case,
you.
we can say that we apply the same concept in action and reaction. So what, even if we consider that micro picoseconds, then can we say that action comes first or then reaction will come?
No, we cannot say action come first or reaction do after that. ये ऐसा हम बोल ही नहीं सकते. This is not defined by Newton. It is not defined by Newton like that. It is our understanding. ये ऐसा आप बोल ही नहीं सकते. All things which we are explaining here in the purview of field, that is altogether different concept. This is the limitation of Newtonian mechanics. That's why the special theory of relativity came out. That is the basic problem.
So
उसका क्या
is it saying that uh, forces will always arise in pair? That means whether if there are two objects, if one exerts force on the other will also exert force on the first. And but if there is a field, and in that you keep a charge, then the field only will exert force on the charge. Charge will not exert any force on the field.
Yes, yes, yes. This kind of concept we have derived now. We have moved from our basic classical understanding to field understanding. And accordingly, all electrodynamics altogether a different subject is derived accordingly. This is the basic underlying concept. Field basically apply force on charge, not charge are interacting each other. Field is important. Similarly, here I am moving very quickly. Suppose Q1, Q2 force is, suppose those two charges are placed like this. One charge is moving like this, another charge is moving with velocity v2. They are separated by Q1, Q2 distance. Then we know very well the electrostatic force or electric field will apply force here in this direction. And here in this direction, there is no confusion. Action reaction are equally equal and in opposite direction. Even it is acting on the same line, all things are going well. But we know the magnetic field, whenever a charged particle moves, it creates magnetic field using this law, and magnetic force is given by this law, where B is basically magnetic field experienced by the charged particle Q. In this particular case, when we find out the magnetic field due to moving charge q2, so this will be like this, and the direction will be towards the plane, inside the plane, right? Similarly, b1 here will be the inside the plane. Force, if you will apply this equation, you will find force will be here, you will find force will be here. What is happening here? Here the action reaction pair are not in same direction, and their magnitude are also not same. Here the Newton's third law, it is not valid here. We can say in magnetic field, Newton's third law doesn't hold. But
No,
what holds? We will see.
here this force, the magnetic Lorentz force, they are not applying on each other. This magnetic Lorentz force is the field is applying on Q1
Yes,
and the
yes.
field is
This
applying on Q2. So as it is,
yes,
we cannot consider these two as action-reaction pair.
action reaction pair also. Yes, we cannot. Even this F1, F2 are also not in truly speaking sense. It is not action reaction pair. But in Newtonian case, we can say, because here also the field is applying the force on q1 charge, and here also the field is applying field of q1 is applying force on q2. So this is also not action reaction pair in strictly speaking sense. So whenever field appears, this kind of things happens. Even contact force is electromagnetic in nature. If we will go on that depth, then even all contact force is also not action reaction pair, because that is only result of electromagnetic force. In the nature, force are divided into four category. We know very well: gravitational force, electromagnetic force, and what another is weak force and strong force. Only four categories there. All contact force are electromagnetic in nature, and none of the electromagnetic is action reaction force in truly mathematical sense. But in Newtonian regime, we assume all contact force, all gravitational force, as even electrostatic force as action reaction pair. But in truly speaking, all these are not action reaction pair. Even this is wrong concept. Newton's third law is absurd concept, but it works in Newtonian regime. Again, I am saying it works in Newtonian regime, but it is not a fundamental concept. So what is fundamental concept? Here it looks like if I am taking this as an isolated system, then its momentum should be conserved. But यहाँ पे momentum conserve होते हुए नजर नहीं आ रहा, because I am getting a net force in this direction. Due to this force and this force, it will have the net force in this direction. This is very important कि Newton's third law sometimes लागू नहीं होता है. एंड थोड़ा सा मैं बस 5-10 minutes more, ma'am, please be patiently listen to me. Which one is you think Newton's as per Newton's third law correct, this or this? Anyone, please quickly, so that we can wind up in 5 to 10 minutes. Case B. Anyone for case A can vouch? Nobody. It is general misconception that case A is not a kind of thing for as per Newton's third law. Even case A is also in. Have you seen any time in Newton's third law? It is given that it will act line joining of two bodies. Action reaction pair will act on the line
Actually, I
joining
think,
of two
sir,
bodies.
the only requirement is they should be in equal and magnitude
Opposite
wise equal
direction.
and opposite direction. So I think what you say is
Direction.
correct. A is opposite direction. There is no need to account for that separation. You are right.
Yes, yes. This kind of thing is not there. So this is also admissible in terms of definition, and even in reality, sometimes we find that kind of force in nature. Just like two magnetic force between two magnetic moments. Suppose there is a coil, and in which a steady DC current is running. This is current carrying coil. They have a small magnetic moment m1, and here magnetic moment m2. The force between two magnetic moments is denoted by like this, and it is defined by a rigorous mathematics. We will not explain or we discuss that kind of mathematics, but yes, you understand this kind of phenomena takes place in the nature. That's why there is two form of Newton's third law. First is weak form, which also include this kind of thing, and second is called Newton's strong form of Newton's third law, which includes only the forces in the line joining of two bodies. Right? what I said earlier,
Sir, in
Newton's
that case,
first,
in weak force case, are the magnitudes equal?
yes, magnitudes are always equal. This is the fundamental requirement of Newton's third law.
But that is
If we say
within the realm of that
Newtonian mechanics,
Newtonian mechanics, right?
Newtonian mechanics,
Not otherwise.
not otherwise.
Hmm.
In general, we say Newton's first law can be derived from second law. This kind of notion we always have. Maybe जब बचपन में था तो I just understood like that. Why we have three laws: first law, second law, third law. Even first and second law are intermixed. If I say F is equal to 0, automatically it will follow the velocity constant or it will be rest. It is always the notion. But the purpose is very clear. Newton's first law is for basically we define an inertial frame, which is basically according to the Newton's first law. What is Newton's second law? On that frame, we want to write basically a equation, and that is basically F is equal to ma. So we cannot say with the help of Newton's second law we are deriving first law. No, the purpose of first law is to define inertial frame. The purpose of second law is basically to write the equation for motion of the body. These two purposes are definitely different things. Don't intermix it. Second, which statement is correct? Sometimes we say by applying second law and third law to an isolated system of the particle, as I described earlier also, law of momentum conservation can be derived. Sometimes we derive also. Therefore, Newton's third law is more fundamental. We just take that kind of note. Newton's third law is more fundamental than the momentum of conservation. But it is absolutely wrong thing. Momentum conservation is related to something very special, which I will just describe in the last slide of this. It is very fundamental and it is related to something special. And law of conservation momentum is more fundamental as the Newton's third law. As I have described earlier, sometimes Newton's third law doesn't hold. In the regime of field, it doesn't hold. So, इसलिए we can say Newton's law of conservation of momentum is more fundamental. It always holds wherever there is no force for an isolated system. Next, as I described earlier, there is a net force in this direction due to this magnetic field. That means there will be net momentum change in this direction if these are moving. But I just said for an isolated system, momentum always conserves. So from where that momentum will come, that part is come from the field, and that field is defined by like this momentum. This is basically we say momentum density g, and it is purely electrodynamics kind of thing, and we defined basically a momentum vector, and after that a change in momentum due to field. Then these two will cancel out each other, and the momentum of entire isolated system, when I say isolated system, means it does not experience any kind of other forces. Under that condition, the momentum conservation of this system will hold. That means momentum conservation is something that always works, and it is very important for us instead of that particular what we say Newton's third law. Newton's third law only work in the regime of Newtonian mechanics. It is not always works.
But here, Q1, Q2 are a system, understood. But then what about the field? That may be all pervading. So do we consider the system to be made up of Q1, Q2 and the field?
Yes. Absolutely. What I'm saying
For
here.
that
This is only
total
what I'm saying.
three things together, the conservation of momentum will hold.
Yes,
Yeah.
Q1, Q2, entire field, and that field is not limited to this particular page or up to this. This dV denotes the volume, and the volume is defined by entire universe, because the field of this Q1 is spreaded into entire universe. That
Correct.
means the limit of this integration is entire universe. I have to go by like that mathematical thing, then only these two will equal each other, otherwise not.
So it doesn't make sense to consider these two as the only. This location of these two is not just part of the system; it is the whole universe has to be considered
Yes, whole universe.
as a part of
The
this.
whole universe. And we are considering there is no other things in the universe.
Correct.
Because now that the concept will be mathematical only, because we know there is different kind of things in the universe.
Okay, clear.
And that will act. Now the next thing, what I said earlier also, this is only one to left there. Each law of motion is independent in both in terms of definitions, never mixed each other, and they have the inherent nature also. Newton is saying something here. Please note that first law define inertial frame. Second law provides simplest form of laws of mechanics. Third law is basically signifies real forces exist in pair. And this law, third law, is basically the geniusness of Newton. It is not inherited from the ancestor. First and second law, you can say it is inherited from the ancestor. Like first law is basically Newton has inspired from the Galileo. And sometimes we also attribute first law to Galileo. And you can say this second law is the extension of the first law in somewhat sense. But the third law is pure geniusness of the Newton, and it is not inherited from the other scientist. I have read some papers in which it is clearly written like that, but I really don't know about the history, but it is attributed like that. But what I said earlier, why linear momentum conservation? Yes, ma'am.
In Vaisha Shakya, it is a sculpture. The three laws are also there in Sanskrit slok.
Okay, sir. Okay. Uh, what I am saying, there is a one important branch that is we called Lagrangian mechanics, and that is now very interesting for me, and in which I found something special. Whatever we are saying, inertia, momentum conservation, something, all these are interesting only because of something we have assumed, or our nature is like this. We say our space is homogeneous. Do you mean what is homogeneous? Homogeneous means in space one point cannot be differentiated with another point. Whatever experiment you are doing on the one point, if you are repeating the same experiment, same kind of setup at another point in space, they will show the same result. That is meaning of the homogeneity of space. Isotropy of the space, it doesn't have any direction, that spatial direction for which the experiment will be differ. No, in any direction, wherever you want to do any experiment, it will show the same experiment. This is the meaning of homogeneity of space and isotropy of space. We have assumed, or our space is behaving like this, homogeneous and isotropy. And similarly, time is basically homogeneous. It continuously flow equably and the same way, and we cannot say 2022 was something different and 2025 was something special. Whatever physical experiment you do in 2022, 2022 and 2025, they will show the same result. That means this is basically meaning of homogeneity of time. And with the help of homogeneity of time, Lagrange has showed the energy conservation theory. With the help of space invariance or homogeneity of space, defines linear momentum conservation. Isotropy of space defines angular momentum conservation. This is basically that broader chunk which Lagrange come out after basically Newtonian mechanics. This is very important aspect, and that's why we defined inertial frame. Why inertial frame is behaving like that? The particle which have no force, it will continue to move because of this nature. Space is, we have assumed space and time like that. Inertia is not, it is very misconcept that inertia is the property of body. No, inertia is not property of body. Rather, inertia is just a definition, and that definitions comes through the space and time. We have defined like space and time. To never attribute inertia is a property of body. Always attribute inertia is the space of body if you define inertia by Newton's first law. Remember, sometimes we always mixed all together things, but don't mix this. Thank you all. This is all what I want to convey. It is already lots of time, but I don't know whether the participant has enjoyed this session or not.
Sir, it was very insightful. Seriously.
So
Thank you so much.
thanks
Thank
to
you, Meg.
Mr. Basu Sahu for insightful talk, providing deep understanding of basic concepts. Dynamical problem solving approach has been discussed with a clear understanding of the physical situation, followed by the identification of all relevant variables and constraints. The choice of an appropriate frame of reference plays a crucial role in simplifying the analysis. We have understood that first frame of reference is to be considered, define system state necessary assumptions, and identify all forces acting on the system through a well constructed free body diagram. This structured methodology ensures clarity, accuracy, and efficiency in solving complex mechanical problems. A classical and insightful illustration of focused analysis is drawn from the episode of Arjun aiming at the eye of a bird, interesting problems on action reaction pair and on the Newton's third law. सर आपके लिए तो यही है, खोल दे पंख मेरे कहता है परिंदा, अभी और उड़ान बाकी है, जमी नहीं है मंजिल मेरी, अभी पूरा आसमान बाकी है, अभी पूरा आसमान बाकी है. So thanks a lot, sir, for such insightful discussions and such a brilliant talk. So now please for the volunteers, so please 2-3 participants are requested to volunteer themselves to provide feedback in the concluding session of tomorrow. And further, assignments have been posted by the resource persons. Please complete these in assignments and submit by 8th April so that e-certificate should be sent to you in time. So thank you very much. Thanks to all. Thank you very much.
Thank you, ma'am, for the kind
मैम
words.
कल
Thank you so
सेशन
much.
कितने बजे है?
सर वो बाद में मैम हम डिस्कस करते हैं.
हाँ ठीक.
हाँ जी.
Thank you.
Basu sir, are you there?
हाँ, yes sir, yes sir.
जो आपने एक बड़ा अच्छा कंसेप्ट बताया था कि एक्शन एंड रिएक्शन कुछ भी हो सकता है, दोनों में से एक एक्शन हो तो दूसरा रिएक्शन है, दूसरा एक्शन ले सकते हैं, वो इट कैन बी इधर वेज. बड़ा अच्छा एग्जांपल जब पढ़ा रहा था 12th क्लास के बच्चों को, इनफैक्ट छोटी क्लास में, तब एक बच्चे ने बड़ा अच्छा उदाहरण दिया था, शायद वो आपके काम आए, कि यदि हम ताली बजाते हैं तो राइट हैंड को एक्शन कहेंगे लेफ्ट हैंड पर, या लेफ्ट हैंड को राइट हैंड के एक्शन पे कहेंगे. सो एनीथिंग इज एक्शन, द अदर वन इज द रिएक्शन.
सर एक बार फिर से बोलिएगा.
बस मैं आपको एक और उदाहरण दे रहा था, जो आपने एग्जांपल बताया था कि एक्शन कुछ भी हो सकता है. तो जब हम ताली बजाते हैं तो राइट हैंड ने एक्शन किया कि लेफ्ट हैंड ने एक्शन किया?
हाँ, राइट. वो हम आइडेंटिफाई नहीं कर सकते क्योंकि दोनों एक साथ बज रहे हैं.
एग्जैक्टली. तो वही जो किताब टेबल के ऊपर कोट्स लगा रही है, इंटर्न टेबल उस पर रिएक्शन दे रहा है, तो एनीथिंग कैन कम एज रिएक्शन, द अदर कैन बी इट्स नॉर्मल रिएक्शन, नॉर्मल फोर्स. तो शायद ताली बजाने का उदाहरण बच्चों को ज्यादा समझ में आता है, इसलिए मैं उदाहरण यूज करता हूँ. तो मैंने कहा शायद आपको ये सुन के.
सर एक और मिसकंसेप्शन भी चलता है कि अगर हम किसी को सपोज एक झापड़ मार दिए तो वो भी हमें इन टर्म्स ऑफ एक रिएक्शन देता है, इस टाइप से चलता है. लेकिन ये बहुत ही खराब एग्जाम्पल है, बट मैंने सुना है यूट्यूब वगैरह में इस टाइप से चलता रहता है. बट वी शुड नॉट यूज काइंड ऑफ दैट काइंड ऑफ थिंग. तो आपका तो चलो अच्छा है, वो तो बहुत ही अच्छा है कि दोनों एक साथ हैं, बट समटाइम्स हैपेंस है। बहुत अच्छा लगा सर आप सभी लोगों से बात करके, मुझे तो बहुत ही अच्छा लगा। और मैंने काफी टाइम ले लिया इनफैक्ट आप लोगों का, और मेरी इंग्लिश इतनी अच्छी नहीं है बट आई ट्राइड माय बेस्ट बिकॉज थैंक यू सर, थैंक यू सो मच, थैंक यू मैम, थैंक यू ऑल।